Yes, it's Tuesday night, and you're here with Mark of Sea Science Film Labs and Jason and Doug of Faithful, Honest, and True. We're going to be discussing the same topic as always, evolution versus creationism. And, I can't wait. We've got a video to discuss tonight. It's a little known debate between Kent Hovind and Mr. Aidan Linden, who is a YouTube atheist. He's pretty well known within the group here. So, how are you guys doing tonight?
Oh, good. Thanks, man.
Good, man.
Good. How about
Glad
we
to
get
hear it.
straight into the debate?
Sure. Yeah, let's play it up.
What do you do with this flood? When fears come in and flood your mind, when you think you're going down, when you think you're not going to make it, when you think you're going to fail God, or you've not measured up, when the enemy comes in and tells you that you're unworthy, you're unholy, you're no good, you'll never get it. What do you do when the enemy comes in like a flood? You see, the Lord raises up a standard. Let me show you what that standard is. Look at verse 1. The Lord reigneth, he is clothed with majesty, the Lord is clothed with strength, wherewith he hath girded himself, and he's put on his armor and set for battle. You have to have a clear vision that your Lord and Savior is standing by, his eyes on your flood, his eyes on you. You have to have a clear vision of what God has promised here. I've not ignored you. I see where you're at. I see what you're going through. Look at me, he says. I have girded myself. I put on my armor. I have my sword in hand. And then read what it says, verse 4. The Lord on high is mightier than the noise of many waters, yea, than the mighty waves of the sea. God says, get your eyes off the flood, get it on me. I've got my sword in hand. I am more powerful. I am mightier than all your floods. I'm bigger than...
All right, glory to God. Everybody, welcome to Proverbs Guys Ministries. We have an excellent debate in store for you today. We have Dr. Kent Hovind, our famous creationist, and we have Aidan Linden, who's going to be here supporting cosmology or cosmic evolution, as it's referred to by creationists. We already went over the format for the gentlemen, and they've both agreed, and we have been reassured that we won't have any personal attacks on individuals, but personal attacks on ideologies are fair game. Saying that, we're going to go ahead and give the floor to Aidan to give us his 5-minute opening statement. Are you ready, Mr. Linden?
Yeah, I'm ready when you are, Stephen.
Take it away, sir.
All right. Well, hello, everybody. I hope everyone's doing well today. Over the course of today, there will be many assertions that my opponent will make towards the field of cosmology. And I would like to make a few things abundantly clear on the outset. While my opponent will attempt to make the assertion that the scientific field of cosmology is part of a religion, what he is attempting to do is place his religious institution, based upon rigid, dogmatic thinking, underpinned by a faith and belief in things unseen without evidence, with that of science, an institution which relies not just upon what we can directly observe with our eyes. After all, if that were the case, the atoms which help operate this universe and the gravity which orders it would have never been observed or discovered, but also what we can test, predict, repeat, and observe through all means of observation to the point that it is consistent beyond reasonable doubt. When Kent conflates so-called cosmic evolution with cosmology, he is attempting to place these two studies on an equal playing field in which they simply do not belong. I intend to demonstrate that to all of you today. Some of those attacks that Kent undoubtedly will make today are going to be arguments that he's already faced many times before by people many times more qualified than myself to discuss on such topics. It's for this reason that I'll now quote from Uptown Sinclair. It is difficult for a man to understand something when his career depends on him not understanding it. I bring this up simply to point something but the audience in general. I am in no way, shape, or form dependent or reliant upon any of these ideas to be true in order to facilitate my living. I contrast Kent with myself.
I
in
had
this-
to turn the quality down because it's it's cutting in and out. And anyway, if we need to look at something, I'll turn the quality up. But in the meantime, so we get like a fluent sort of thing, I'll just leave the quality right down.
Sure, sure.
this
And if
example,
you
simply
turn
to
off your
illustrate
mic
the
when
difference-
if you want to turn off your mic while it's playing, it might help too.
My mic coming through? Is my mic coming through? Have you heard anything? Just
Oh no,
Since-
there's no feedback or anything. I just mean it might help with the video.
oh no,
I don't
no. If you can't hear it, then that's fine. It's
Okay.
fine. So let's
All right.
let's keep going. All right.
It's between myself and someone who has made their career out of cosmology or creationism. I have no dog in that fight, and I hope that this will lend a lens of perspective to Kent
Jesse, join us.
and the audience at large moving forward in the debate. The history and study of cosmology contains within it some of the most towering figures of intellect that we have ever had in our history. Figures such as Edwin Hubble, Alexander Friedman, William Herschel, Galileo Galilei, and Johannes Kepler. While some of you at home may be wondering why I excluded some notable names from this list, I did it intentionally, because all 5 of those men just listed were all Christian. While Kent will try to claim that these pillars of our cosmology are there simply to distract or take us away from Scripture, none of these men, among many, many others over the history of cosmology, have had to face the same issue. All of those men understood that the Scripture makes it abundantly clear that any man who turns away from God because his creation does not meet their expectations is a fool. And not only this, but that truly strong faith will not be shaken by any evidence that is brought forth into our reality. Suffice it to say, these claims are not true on Kent's part, and these great men of our scientific past stand as sentinels against that mistruth. With all of that said, I do hope that Kent proves me wrong. I hope that he comes at me with unconventional arguments that I have not prepared for. And I hope that he proves, above all else, that I am wrong about his misconceptions of our sciences over the course of this debate. And with that, I yield the rest of the balance of my time to Kent.
Stephen, do I just start? Are you going to say something? Or hello, hello?
Stephen
Yes,
was
the floor is
okay.
yours, Doc. Go ahead.
Okay. I'm curious why Aiden doesn't show his face. I mean, I'm not afraid to show mine. Is there something wrong here? Anyway, you can do that later if you'd like. First of all, I think you made a serious error in your very first statement. I'm not against cosmology. Cosmo, the study of the ology, the study of the cosmos, the study of the universe, I'm in favor of it. The problem is, you guys want to include something in a good science called cosmology that is not science. It is not science to teach all the planets and stars and everything came from a dot smaller than an atom. I'm not against cosmology, Aiden. I'm against the Big Bang religion, and it's nothing but a religion. They teach the kids, they have their pictures showing everything starting from a dot. Here we go. European Space Agency. Can you make mine larger there, Brother Steve? Okay. Did the universe start smaller than an atom? Here's what they say. Time, space, and matter all begin with the Big Bang in a fraction of a second. The universe grew from smaller than a single atom to bigger than a galaxy. That's got nothing to do with cosmology. Cosmology is the study of the cosmos. I'm for it. Study it. And I think you'll find there's a whole lot of stuff out there that will not fit in a dot smaller than an atom. This
What?
statement this European Space Agency made is stupid. That's not, stop and think. You really think all the matter in the universe fit in a dot smaller than an atom? You really think all the Himalaya mountains fit in a dot smaller than an atom? You really think the planets and stars and everything came from a dot smaller than an atom? I'm not against cosmology, Aiden. I'm against the Big Bang religion, and it's nothing but a religion. They teach the kids, they have their pictures showing everything starting from a dot. Here we go. European Space Agency. Can you make mine larger there, Brother Steve? Okay. Did the universe start smaller than an atom? Here's what they say. Time, space, and matter all begin with the Big Bang in a fraction of a second.
There you go.
The universe grew from smaller than a single atom to bigger than a galaxy. That's got nothing to do with cosmology. Cosmology is the study of the cosmos. I'm for it. Study it. And I think you'll find there's a whole lot of stuff out there that will not fit in a dot smaller than an atom. This statement this European Space Agency made is stupid. That's not, let's stop and think. You really think all the matter in the universe?
Let me just say something now. There was one time at CERN where they actually created gold out of by ramming particles into each other. And what they don't tell people is this: is they say they created gold out of nothing because they smashed particles into each other and gold appeared from two particles that had nothing to do with gold, basically. But the gold only appeared for a few seconds or a split second or something and disappeared. Doesn't matter. They created gold, right? And they say it was out of nothing. But what you need to understand is that that all matter and energy, all matter is energy. Gold, atoms in gold are all energy. Atoms in your table, phone, glass, everything is in energy, right? So you've got energy in that everything, all matter is made up of energy. So they smashed energy into energy, and that energy created some gold particles from, so that is not like creating something out of nothing. That is literally creating gold out of something and just rearranging the particles, just like
Collider.
Yeah.
Sure. Yeah, and I wanted to add as well that, as Hovine pointed out here, cosmology is the study of the cosmos more than it's the theories surrounding that study, which would be like the Big Bang Theory and other cosmological models rather than the observed cosmology. So, but yeah.
The right shoulder. Oh.
Does Doug have anything to add to that?
I'm a bit lost here. I missed the last bit because I went.
CERN,
cosmology. Not a problem.
Where they're creating everything out of nothing.
Yeah, well, that's just an anachronism. It's rubbish. Nothing
Absolutely.
creates nothing. I mean, it's common sense. I mean, it doesn't take a genius like Jason or anything to know that. So,
And it's
par for the course.
It's like when you smash atoms into each other, and those atoms that had nothing to do with gold create gold particles. It's not creating it out of nothing. It's just rearranging that energy into. So that comes down to this. There's something else that's interesting with this, because Jesus Christ turned water into wine, right? So he rearranged the molecules. So how much energy does it take to rearrange molecules? Just for Jesus Christ to create that one miracle, would it take more energy than all the nuclear bombs on Earth, right, to rearrange the molecules? So that what I mean is, it's CERN, when they smash those particles into each other, they're smashing particles into each other at a massive high velocity and energy and power in that, which is producing gold, which is energy, which is producing these other particles, which is energy. They did the same thing with the Proton 21 labs. They basically, what they did is they put in a massive amount of energy into a small copper particle. And out of that particle, they got more elements that were in the periodic table. The elements that weren't in the periodic table lasted for vanishingly small times, very small times. But even the elements that were in the periodic table burned away without creating heat within a small amount of time. and they repeated those studies 5,000 times around the world in different laboratories. So when you repeat something so many times in different laboratories done by different scientists and get the same results, so you're looking at basically they literally turned just a tiny piece of copper, right, by putting a massive amount of electricity into it and just exploding it. They turned it into every element on the periodic table and then
Wow.
some on top of.
Wow. Well, then
And-
they've successfully accomplished alchemy, or like the goal of the first alchemist.
But the thing is that when those like uranium and that burn out, it burn out to the same ratios what we have today. So if you have they say that there's been so many billions of years and there's so much yellow cake on Earth, right? And they say, so okay, so you got all these billions of years, you got all this uranium on Earth. Well, we should have way more lead than we actually do, right? And then what they say is because of all this time that all these heavy elements should have sunk to the core. But that's another big problem, because why do we still have massive gold deposits and massive lead deposits and massive deposits of uranium all on the surface of the Earth when it's so heavy it should have sunk to the core, right, over billions of years? There's just so many things, and I think Kent might bring up some of these things. Do you want to add to that, Sea Science, before we go on with this, or what?
Well, I don't really get into the subatomic particle physics as much. So no, I'm good right now. Other than just to reinstate that cosmology is the study of the cosmos, and it's not the cosmological models or
Theoretical science
theories.
It's
Yeah, cosmology is actual science, whereas the Big Bang is more like a theory surrounding the science. So.
It's theoretical science. It's not an actual theory. Like it's the Big Bang is theoretical science. There's a difference. There's a difference between a theory and theoretical science. Like there is no evidence whatsoever for the Big Bang. There's no evidence. So it's literally just a weak, flaccid hypothesis that's being portrayed as a theory. Yeah. It's got no evidence at all.
Yeah, they have phenomenon in the universe that they claim is evidence, but it's not really evidence for it. Like they'll claim the CMB, or the cosmic microwave background, is evidence for the Big Bang, but that's just a phenomenon that they don't really know the source of. So instead of claiming, we don't know, like they should honestly, they're using the Big Bang of the gaps logic there, for sure.
Yeah, CMB. Yeah,
with their Big Bang of the gaps logic. Anyway.
Exactly, I agree.
Good. I've got a doc here that, hang on, reference to this document. Actually, there's something that, what I'll do is I'll just get this.
Did you think of a document for cosmology? Or
no, it's not that. I want to play a video from.
Okay. Yeah, I was just I'm gonna reinforce this while you're figuring that out. Hovind, he understands the difference between science and the theories that surround it, the models that people have created surrounding the science, the beliefs that people hold, the experimentation, and the method used to gain the knowledge that we call science. So that's where a lot of the YouTube atheists fail, is they seem to believe that these theories are also science, and this is not knowledge. It's simply beliefs. So.
All right, well, let's play on.
All right.
Actually, there's There's one thing I wanted to play about this distant starlight problem, but we'll play it later. All right, here we go.
All right.
fit in a dot smaller than an atom? You really think all the Himalaya mountains fit in a dot smaller than an atom? You really think all 8 billion people on the planet, that's the ones alive today, plus the ones that died, all came?
When he says a dot smaller than an atom, right? What the evolutionists mean by that is something different to what Kent means. Like the evolutionists believe that that dot smaller than an atom, like that was a million trillion times smaller than an atom, had zero energy. And that's why it could stay in existence for so long, because if it had like all the energy of the universe in it, like this quantum fluctuation put in there by a quantum fluctuation would have been gone immediately, like infinitesimally gone. Right? So it needed to have zero energy to be able to stay in existence. And that's why these virtual particles that we hear about pop in and out of existence constantly and have very small times in existence. And they can't actually see them, but they can see their effect they have, right? So it's that's what, and maybe it'll get into that later on, but let's keep going.
Came from the dot smaller than an atom? Yes, water can be compressed. If you start at room temperature at 1 atmosphere, you have liquid water.
But it's not water being compressed in the atheist model, and that's where he's getting it wrong, and that's where they're going to attack him. It's literally what they're talking about is just a something that, like, what they say is the whole universe has zero energy, right? Look, all the suns and everything. So they're literally saying that this singularity had no energy at all. And all the matter and energy in the universe, because it's half positive, half negative, it cancels each other out and actually equals zero energy. So this is where they have a bit of a confliction in here, but it's still interesting to watch Kent go on with this.
Compress it to 1 gigapascal, it becomes a solid. Compressing water into ice is relatively easy with specialized equipment, taking a few thousand atmospheres of pressure. It takes a few thousand atmospheres just to squeeze water into ice. Now, to squeeze all the water in the ocean down into a dot smaller than an atom is impossible. Where's this pressure coming from? I'm just pointing.
There is no pressure, according to their cosmology thing. There's no pressure because there is no energy. We're literally looking in their worldview at a singularity, a magic dot, as Kent puts it, with zero energy. And that's why it can stay in existence. If it had any energy at all, the more energy it has, the less time it has in existence. If these quantum fluctuations that are popping in and out of existence, if they have zero energy, like the quantum fluctuation that started the universe, the singularity that started the universe, then it could inflate. And in that inflation, because it's got zero energy, create all time, space, and matter without violating the laws of physics.
No, it doesn't.
I know
Zero
that.
equals zero.
Yes, Doug,
It's
of
not
course.
that complicated.
That's not what we're talking about, but yeah, that's what they're basically saying. It's just, yeah, it is. They're insane.
It is.
They literally try to say that all the energy, like you and me, or your
Zero
flames,
equals
everything
zero.
it means
Mathematical equation.
it means zero.
Engineered. Zero equals zero.
Yeah. Anyway, let's go.
Out the Big Bang is not science. It's a religious belief. I'm not against cosmology. I'm for it.
It is.
And you said, I don't understand something because my career depends on it. Well, that's a slap in the face, Aiden. I understand it completely. My career does not depend on this. Your career might, I don't know. But there is no scientific way you can compress all the water in the oceans into a dot. They were able, with 3 million atmospheres of pressure, using a metal organic framework, they reduced the volume of water by 7%. They were able to squeeze water down 7% using 3 million atmospheres. And you want to think that all the water in the oceans, there's 333 million cubic miles of water on this planet. That's just on the surface. That's only about 1.5 miles, 2 miles thick. The whole planet. You really believe the whole planet Earth fit in a dot So stop saying I'm against cosmology. I'm against including Big Bang with cosmology. Big Bang has nothing. Big Bang is a religious belief. I'm not against science. I'm against including evolution with science. These stupid charts that they make. Did you ever get me another one, brother? Okay. Those stupid charts they make with everything related to a common ancestor, that's not science.
What do you stop it for?
Because I can let people see it.
No, I wasn't listening.
Yes, we're listening, but anyway.
No, I can't.
Doggone, stopping. So just wait, mate. Wait.
It's science
Yeah, so
to say
again-
dogs produce dogs and cows
I was just trying to fill the dead air. You can play on, brother, when ready.
produce cows. That's science. It is not science to say dogs and cows have a common ancestor with a tomato. You guys try to sneak your religion in under the guise of science and cosmology. The study of cosmos is wonderful. We got a bunch of telescopes here. Come on up, sit on our deck on the back 40 and watch the stars. There probably are, let's see, they estimate there are 40 billion Earth-sized planets orbiting different stars around our galaxy. That's the current estimate. You couldn't squeeze a cup of water into a dot smaller than an atom. You certainly aren't going to squeeze the whole Earth, let alone 40 billion Earths. That doesn't include the stars. You think all 1.5 billion cows fit in that dot smaller than an atom? Okay, this guy says it's roughly the size of a human being. Well, it's bigger than an atom, but you couldn't squeeze all the cows into a size of a human being either. This is just plain baloney. And you start off, you're lost in the first few minutes. I'm not against cosmology. I'm against the Big Bang. The Big Bang is not cosmology. It's a religious belief to explain the origin of time, space, matter. This one says the Big Bang was a moment 13.8 billion years ago when the universe began as a tiny, dense fireball that exploded. And they use the word explosion, okay? Whether you want to call it explosion or expansion faster than the speed of light, I'd say that's an explosion. It's arguing about trivia. The fact is, you do believe, or some of your friends may believe, that matter came from nothing. The first long-lived matter particles of any kind were protons and neutrons. These came into existence around a 10,000th of a second after the Big Bang. That is not a scientific statement. That's a statement of great faith.
Dr. Hovind, that's time.
Okay, so I'm not against cosmology. Thank you.
We're going to go ahead and give it back to you now, Aiden. You have 10 minutes to go ahead and defend your position. And as soon as you begin speaking and unmute your microphone, I will start your timer, sir.
Yeah, sure, not a problem at all. So as far as Kent's, well, one of his many claims that he ended up alluding to at the very beginning of that, he does not rely on this for a living. Of course he does. Of course he relies on this for a living because if Big Bang cosmology was something that he taught, in his view, it somehow is it's something that cannot be equivocated with biblical cosmology. Those two things are simply incompatible in his worldview. So of course it naturally is dependent upon his career that he not understands this. The reason why I said that as a so-called slap in the face, as he said, Ken, is because these concepts have been explained to you numerous times on numerous occasions, and the questions that you ask in the face of those times that you've had those things answered are not questions that are based on any sort of advancement of knowledge in the face of those answerings of questions. They're just simply you asking the same questions over and over and over again in perpetuity, as though you had never had those questions answered in the first place. It's not an honest way to be able to carry forward your understanding of things, and that's certainly not a scientific way of carrying forward your understanding of things and expanding it so that you might be able to portray a more better and accurate picture of the sciences to people that are dependent on you for that kind of information. That's why I said those sorts of things about you, Kent. In relation to the Big Bang, well, the main crux of your argument was essentially incredulity. You think that this large amount of things came into being from this tiny amount of space. Well, Kent, the size of the singularity, the time that the singularity had within it, and the time that was without it, all of those things are not things which the Big Bang Theory addresses. The Big Bang Theory simply addresses what happened directly after t equals 0 and addresses the rapid expansion of the universe that happened directly afterward that period of time. So just because you're incredulous of that, because humanity isn't capable of replicating those exact same conditions.
Because humanity's not capable of replicating those same conditions. What? You're going to replicate a singularity that's coming into existence that has zero energy so it can stay in existence longer. And because it has zero energy, it expands at 10 to the 58th, which is 10 octazillion kilometers per second, right, within itself. But it's not breaking the laws of physics because it doesn't have any energy. And that the universe we're living in doesn't actually have any energy. It's zero, according to them. So, and that's why it could, it's expanded and kept expanding to this date. But he's not telling you that. And Kent doesn't know this, I suppose. But
that would only be a valid argument. Well, we can't do it now, therefore we can never do it. It's just simply impossible. It's an immovable mountain of scientific fact that we can't do it because we can't do it now.
He just said it's an immovable mountain of scientific fact that we can't do it. That's true. It is. It's an immovable mountain. You can never, ever prove or disprove this. It's impossible. The Big Bang can never be proved, ever. In the same way that we can't prove God definitively, ever, right? Like,
yeah, that's exactly why I compare it to the Big Bang of the Gaps, to the God of the Gaps argument they're always throwing at us.
That
you know
would
what I mean?
be true if science was a dogmatic.
Yeah.
Okay.
Institution. But as I've already pointed out to you, Kent, science is not a dogmatic institution. Science is an institution which is constantly changing its understanding of things based on new information. And part of that new information is facilitated through new technologies, which we are able to come up with, which have helped to facilitate not your worldview, but rather the view of Big Bang cosmology. Even people that I had mentioned in my opening statement.
Where's this evidence that's facilitated the Big Bang cosmology? And facilitated means proven.
He's talking about the CMB. He thinks the CMB is unquestionable evidence for the Big Bang. Mm-hmm.
Oh, okay. So how about we just stop here and we go to another video about the CMB, because I know where this is going. This video is just going to be all right, so here we go. Oh, wait a minute. Let me hang on.
And I'll drop the link to that debate in the chat for the people in the live chat if they want to check it out later after the show, or even now, I guess.
Just let me play this while I find it. Let me play this while I find it.
All right. So yeah, since we're going on to the other video, I don't know if you guys can hear me, but I just wanted to review what we heard there. And that was Hovind. He said again and again, the Big Bang is not cosmology. And he's right. It's it's a model that surrounds cosmology. So he understands, I'm saying Hovind understands the difference between science and the theories, the opinions, the beliefs, the experimentation that surround science. He understands the difference between the knowledge gained through the systematic method we use to gain this knowledge, to gain the new science. So science is basically the entire body of knowledge that we've gained over the years through experimentation and the scientific method. But the scientific method and the experimentation itself isn't the science. Science isn't done, science is known. So and beyond that, I think yeah, we didn't really get into much more than that in the intro. So are you still with me there, Jason? If not, I'm gonna have to come out with some photos here. Look at this.
Yeah, I'm here. Hang on. I'm just trying to find. Yeah.
All right.
I find.
All right. Throw that in there for people to read.
Hang on. I just don't know if this is the.
Thank
the
you, Phoenix,
one.
for the sound check. That's good. Okay.
Are we
Get that out of your way.
playing? Yeah, so I can see. All right. Hang on, let's have a look.
I am the 7-foot apologist. In case you were wondering why I call myself that, just take a closer look. I feel a little self-conscious now because, Chris says that, when they try to find speakers to speak here, they look for somebody with a background in science. And when that fails, I guess they bring out the former basketball players. So here I am. My background, I have a Bachelor of Science in Electrical Engineering from Northwestern University. That's in Chicago. Basically, a BSEE means you know how electrons work and you don't know anything about the practical world. So I have that degree. I never used it because right out of college, I went and played professional basketball for about 3 years. And it turns out I was a much better web developer than I was basketball player. So that didn't last very long. So I got a job as a software engineer at Amazon.com and worked there for 15 years, 10 months, and 11 days. Not that I was counting or anything. But I survived. I'm one of the few. And in 2003, I started teaching 6th grade what I call theology and apologetics. I usually don't like to call it Sunday school, but it is what it is. So you're looking at this and you're going, okay, this guy's going to give us a talk about the distant starlight problem, cosmology, cosmogony, and all of that. There are no ologies in your background, Dan. It sounds to me like you're unqualified. And yeah, I would tend to agree with that. But I think I'm in good company because there are lots of people who are unqualified to do what they did. And I want to introduce you to a few of them. The first guy I want to introduce you to is the guy who is responsible for the whole field of electromagnetism. Michael Faraday discovered electromagnetism. He invented the Bunsen burner, of all things. He discovered the benzene molecule, and he made the first electric motor and generator. Without this guy, I wouldn't have a degree in electrical engineering because it probably wouldn't exist. He's regarded as one of the most important scientists of our time, but this despite the fact that he had only a rudimentary education, and he worked as a lab assistant, of all things. I guess that explains the Bunsen burner, right? So you might say that he was unqualified to do what he did, unqualified to be one of the most amazing scientists of our time. William Herschel discovered the planet Uranus and also infrared radiation. This despite the fact that he was but a music teacher and a composer. Talk about operating outside of your field of operations, right? He was definitely unqualified to do what he did. And then my favorite drummer of all time, Phil Collins. Phil Collins, I don't know if you knew this or not, but the man can't read music. And by his own admission, in a song that he wrote and sang with Genesis in the early 90s, he can't dance, he can't sing, and he can't talk. So you might say that he was unqualified to be one of the biggest pop stars of the 80s and early 90s. But that didn't let it stop him. So now the question people usually ask me at this point is like, okay, so you're unqualified, but you're still giving this presentation. How in the world did you get into this mess? Why are you doing this? Well, it all started, as the story goes, a long time ago in a galaxy far, far away. Well, no, that's not true. It actually started about 2 years ago in an email. I'm the author of a book called Jesus is Not the Answer to Every Sunday School Question. And when my book was still in manuscript form, I was trying to solicit endorsements from prominent Christian apologists. So I got my manuscript into the hands of a couple of apologists, and one of the guys wrote me back. Within 2 weeks, he had read my manuscript, and he got back to me. So I was pretty stoked by this. His email starts like this. Hey, Dan, I think your book is fresh, creative, and practical. I know it's going to help many, many Sunday school leaders and students. Oh, yeah, I'm getting an endorsement. This is sweet. But I had to keep reading because the email continued. To be honest, I have just one hesitancy, the fact that the book takes a hard line on the age of the earth. Personally, I feel very strongly, based on scripture and science, that kids need to be taught different views on this issue. I meet too many young people who feel that young earth creationism is the only option for their faith, and so they jettison Christianity entirely when they learn of the scientific evidence for an older earth. Oh, so close. So close. If you're dyslexic, you'll have to ask somebody who's not, because this won't make any sense to you. But as I ruminated on this email that I got from this guy, it really hit me in my heart. And I'm like, okay, what do I do? Do I back off of my position, knowing this is what I firmly believe Scripture teaches, or do I stand strong and just take the hit? I don't get an endorsement. So I decided to stick to my convictions. But this really got me to thinking that at that same conference where I met this Christian apologist, there was another guy who got up on stage, and by the name of William Lane Craig. You may have heard of him. He's probably the preeminent Christian philosopher of our day. I don't think I've ever seen a debate where William Lane Craig was in that he ever lost. The man is amazing. He's got a brilliant mind. Somebody at the conference who was braver than I, asked him a question. They took the microphone during the Q&A session. They asked him a question about something he had said during one of his presentations, where he had kind of spoken positively about the Big Bang. So the question was asked, and William Lane Craig replied with, when you think that we can see the stars billions of light years away, shows how ancient the universe is. That the world was created a few thousand years ago is so ad hoc and artificial, it strikes me as far more plausible to think that these distant objects have emitted this light, and therefore the universe is very ancient. A prominent Christian apologist subscribes to the 4.6 billion year old Earth and a 13.8 billion year old universe. But then that got me to thinking even more, like, wait a minute, 10 years prior at the Worldview Apologetics Conference, I was the guy who asked the question. I grabbed the microphone in the Q&A session, and I stood before none other than Norman Geisler himself, whom we lost just this last July 1st, God rest his soul. The man was a giant of Christian thinking. I think he wrote something like 80 books, and anybody who's ever written any books on Christian apologetics has cited Norman Geisler. I asked Dr. Geisler what his stance on the age of the earth was, and he said this to me. On Monday, Wednesday, and Friday, I'm a young earth creationist. On the other 4 days, I'm an old earth creationist, but I'm cheering for, and I'm praying for, and I'm hoping for the young earthers to be right, but I'm not betting on them. I thought that was a very curious response, so I pressed him a little bit on it politely. I didn't want to start a debate with, a brain twice the size of mine. And Dr. Geisler had this to say. He says, I think the speed of light is the crucial thing. If you could prove that the speed of light changes, you'd probably convert me to a young earth creationist. Fascinating. And I think this just goes to show you, as if you weren't aware already, that young earthers have a distant starlight problem. We have a problem with distant starlight. The problem looks like this. If the universe were only 6,000 years old, we would not be able to see anything in the nighttime sky more than 6,000 light years away. However, we can see stars that are billions of light years away. Therefore, the universe must be billions of years old. The math is not that hard. But what you might not know, and many Christians don't know, is that old earthers also have a distant starlight problem, only they call it the horizon problem. Here's what their problem looks like. Their problem is the Big Bang model predicts hotspots in outer space, and we'll get into this. The fact is that there are no hot spots. The cosmic microwave background radiation is remarkably uniform. Bear with me, technical stuff, but I'll explain it. Therefore, the universe cannot be 14 billion years old. Okay, so let's take a look at this. The cosmic microwave background radiation is supposed to be a remnant from the Big Bang. The Big Bang is said to have happened 13.7, 13.8 billion years ago. And as we look into outer space, this as far back as we can see is within, I think it's 300,000 years of the Big Bang event. And beyond that, space is opaque, so we can't see it. Well, as part of the Wilkinson Microwave Anisotropy Probe, WMAP, that's a mouthful, they sent out a satellite and they took temperature measurements of the visible galaxy. So they're basically just out there scanning for microwave radiation. And after 9 years, they put together a false color map that shows the background radiation of the universe. And this is what it looks like. You see we have little splotches of red. Those are the warmer areas. And the big blue splotches are the colder areas. Just a couple slides ago, I just got to tell you that there are no hot spots in outer space. But yet you can clearly see a bunch of little red spots out here. So those are the hot spots. But what you don't see here is that the difference in temperature between the hot spots, the red spots up here, and the dark blue spots is on the order of 200 microkelvin. That's 200 millionths of a Kelvin. Or since Celsius is the same size degree as a Kelvin, they're just shifted over 273 degrees, it's 200 millionths of a degree Celsius. So that's the temperature difference between a red spot and a black spot. Well, what does that mean? That's a really small temperature difference. Let's put it in terms we can understand. The human body can detect temperature differences on the order of 0.02 to 0.03 degrees Celsius. So if I were to take the temperature of this room and rapidly raise it or lower it, 0.02, 0.03 degrees Celsius, most of you would say, yeah, I just felt the temperature change in this room. That temperature difference, that small temperature difference that we can just barely perceive is 1,000 times greater than the temperature difference of what we see between the hot spots and the cold spots in the cosmic microwave background radiation. Well, why is this a thing? What's the big deal with this? Well, according to NASA, distant regions of space in opposite directions of the sky are so far apart that assuming standard Big Bang expansion, they could never have been in causal contact with each other. This is because the light travel time between them exceeds the age of the universe. And you see, from time to time, you'll see little QR codes here. If you want to take a picture of that with your smartphone, it'll take you to the URL where I got this quote. And I have a few of those within the presentation. Okay, so does this help? I'm glad it helps you because it sure doesn't help me. I feel kind of like Beaker when I read that. I'm just like, huh? What, heat, light travel time? What's this all about? Well, in order to understand what's going on here, we have to talk about how to move heat from one place to another. There are 3 ways we can move heat. The first is via what we call conduction. If you've ever placed bacon on a hot pan, you know the magic of conduction. When a hot thing and a cold thing come in contact with one another, the heat from the hot thing flows into the cold thing and turns it into beautiful crispy bacon. I see some of you aren't reacting favorably. Perhaps you're vegetarians. I have some vegetarian bacon up here for you. So whether you're dealing with bacon or okra, you put it on the pan, it gets hot. It moves into the okra or into the bacon, and you have conduction happening. Well, you can't do that in outer space because everything is so far apart. So that's a no-go. The second way to move heat is via convection. If you ever watched it, we've got hot air balloons that fly around this area every summer. It's really neat. It's really fun to watch. Have you ever watched them fill one of these up? It is so cool. They've got like the world's biggest flamethrower, right? And they just hold it in front, like every kid's dream, every boy's dream. Like, well, you never see them walk into the hot air balloon and just, they don't have to do that. Well, why? All the heat is down here. How does the heat get to the end of the balloon? I love this. Well, what happens is we get what we call convection currents. So the hot air down here, convection requires two things. Convection requires a flowable medium, something that'll flow, like air or water or molten steel, whatever you have that'll flow. And it also requires gravity. So what happens is, as you heat the air at the bottom of the balloon, the hot air is less dense than the cold air. It flows up, it pushes the cold air down because of gravity, right? So then you get these currents that form in the balloon, and that distributes the heat. The same principle applies in your water heater. If you have an electric water heater, you'll have two elements. You have one up top, one down at the bottom. And as your water heater elements don't have to swish around, they just stay in one spot. Because what happens is, as the element heats up, the hot water rises, and it causes convection currents within your water heater. So you can learn something practical in an apologetics symposium. You should come here more often. All right. So, but you can't do that in outer space because of two things. You don't have a flowable medium because space is a vacuum, and there's no gravity. So even if you did have a medium, the air would just keep going up. There would be no convection currents. So you can't do that in outer space. Now, if you're like me and you're 7 feet tall, and you've ever walked into the big box store and you felt your face start to melt, it's probably because you walked in front of one of these things, a dish heater. The dish heaters don't operate on conduction unless you're foolish enough to stick your finger in through the grate. And they don't operate on convection currents. What these operate on is a principle called radiation. So you get radiation coming off. Now, the interesting thing about radiation is it's light that you can't see. You ever thought about that? So when you're walking through the big box store, and suddenly you feel like your face is going to melt, like the old movie Raiders of the Lost Ark, it's because you walk in front of these guys and you're 30 feet away from the heater, yet it's melting your face. Well, that's radiation. That's infrared radiation, probably, that's coming off of that heater, and it's warming your flesh. So radiation is how we move heat from one place to the other. It's the only option available in outer space. So what does that mean for us? Well, let's put it in terms that we can understand. I got a picture here of the Earth sitting in the middle of space. So according to the Big Bang timeline, the Big Bang happened approximately 13.8 billion years ago. So it stands to reason, as we look in the nighttime sky, aside from anything weird going on, we should be able to see about 13 billion light years in any given direction. That's how long the light has had to get to us. All right, so we've got two pieces. Let's have a bit of matter over here. Let's take a coffee cup. We'll put it on one end of the visible universe. And then on the other end of the universe, we'll put an ice cube. An ice cube. That's the wrong ice cube. Sorry, different crowd. So, different ice cube. So you have an ice cube on one side of the universe and a coffee cup with a bunch of hot coffee in it on the other side. Well, according to the predictions of the Big Bang model, this is kind of what you should see in outer space. You should see big hot spots on one side, and you should see much colder areas on the other side. You should see a bunch of clumpiness. But you don't see that. And this is a problem for the old Earth position, because in 13 billion years, the heat from this coffee cup has only had enough time to reach the Earth. And the heat emanating from the ice cube, it does have heat. It radiates heat. Very small amount, well, for us. Its heat energy only has time to reach the Earth. But in order for these two spots to reach equilibrium, right, the same temperature, the heat energy from over here, the coffee cup, has to go all the way across the universe, interact with the ice cube, and the heat from the ice cube has to go all the way across the universe and interact with the coffee cup, and this has to happen many, many, many times before equilibrium is reached. The universe, as we see the cosmic background radiation, remember the pretty false color map I showed you, is basically very, very close to a state of equilibrium. We shouldn't see that, according to the Big Bang model. So, but obviously nobody has rejected the Big Bang. Well, the old Earth cosmologists have not rejected it because they have a solution. Their solution is called cosmic inflation. Cosmic inflation is a construct that was dreamed up by one Donald Guth in the early 80s. There you go. Shortly thereafter, he was joined by Paul Steinhard And
Hey,
Andre
welcome to the
Lynn.
show, Pete.
Between these three guys, they came up with this theory that solves the
Welcome. Glad you joined us. Yeah, we just kind of discussed the creation versus evolution debate here. You know, that old chestnut. So I'm sure you'll feel pretty comfortable.
Is that the same P Town that I know from Praise's channel?
No doubt.
Yes. There's one thing out there. I lost my voice. It's coming back, but I might have to bug you out if I can't talk.
That's all right. No, that's right. We can hear you clear. As.
Yep. Mike's a little bit cracky, but it sounds good.
It's crackling.
You clear. You like a little bit, but we can understand it.
Yeah, you're clear. Yeah.
See these AirPods, if they're starting to crackle, I can't.
It's crackling a little bit.
They're too. Yeah, I don't like it. They're too expensive.
We can understand every word you're saying. We can understand every single word. Like there's no words that are inaudible where we can't understand.
Yeah,
them.
it's just a little crackling.
Crackle. Actually, the crackle's disappeared now. There you go.
Well, I'm not talking.
Yeah, that's the thing.
Is it still there? Yeah.
Yeah, a little bit, but it's not bad. It's really not.
No, it's almost completely gone. No, really, I'm not pissing in your pocket. I don't tell lies.
Either way, I wanted to add
Yeah.
about this distant starlight problem that he brought up. And I know his explanation, and I like it. You know, he's got a good explanation too. But I think one that's more biblically sound would be that the contents of the universe were created with given age, that they were created spread out. You know, they were manifested spread out in the beginning. That the light of the stars was already reaching the planet Earth in the day that it was created, according to the Bible. So there was no time period where the light of the stars didn't reach the Earth in our creation model. You know, if you want to hold a biblical one, you could see the stars in the week of creation. So
I've always wondered. I bet you. Well, I've always wondered, based on my interpretation of Scripture, if they were able to measure the speed of the light from the stars, and if that speed is actually slowing down over time, I think it would be evidence for Scripture. So that's my suspicion, is that even though, God made light in its moving form, he also stretched out the heavens. So I think that maybe that he also stretched the light out, even though he created it in its moving form. So it's just a theory, something I wish I had the ability to test. It's got to be really hard to measure distant starlight speed. I mean, how do you do that?
Yeah, I mean, for me, I think that the distance to the stars, at least the ones that they're measuring with the Webb telescope, these new galaxies and the stars in those galaxies, I mean, it's really more of a guess hinged on another guess, which is the supposed age of our universe. So
I agree with you. I agree with that, but I think it's easy to defer that they are really, 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 really far away.
Oh yeah, I have no doubt that they're far away, but that's the thing. Like for us as young Earth creationists, like we're already assuming this entire universe for absolutely free, So we've got that going for us, and then like here you have the light from the stars already reaching the planet Earth in the week it was created. So even if the light was moving at infinite speeds in the first place, I don't know how it would slow down slowly. It would have to have been instantly there, because the amount of distance that it would have to span, even at the creation of the universe, would have been crazy. Because you got to think, like, with the universal rate of expansion, we're only going to go back 6,000 years of that expansion. Like these Big Bang cosmologists are assuming 27 1.6 billion years of the age of the universe now. They've doubled the age of the universe just because of the findings of the Webb telescope. So,
Well, at the same time though, watch. I can't explain it because I did this years ago. But watch, they're going to discover that starlight is the speed of starlight from distant stars is decelerating, and they're just going to say, "Oh, well, that's just because they're moving away from us at a faster speed each time." Watch, I bet you it's going to happen.
well, sure. I mean,
And
that's
so it's not going to be.
basically a
It's not going to
claim
be.
of relativity.
Yeah.
That's the
it's
whole
not gonna-
idea behind relativity there, Einstein's theory. They're on the train and they saw another train going by them at a different speed, and it looked like it was moving slower than it actually was because they were moving along with it and whatnot.
That's what they would
the
say.
same idea as redshift, But the thing is
Yeah.
you have this light from the stars of all the vast distance of the cosmos already reaching the Earth right from the very beginning of creation. So that to me says
God made
that
it.
there's a model of the Bible where God actually created the contents of the universe already spread out. In fact, so spread out that we would only have to go back and, we can't go back in time, but we would reverse the current rate of expansion back 6,000 years instead of 27 billion. And that's about where we'd have expected the creation of our universe to start. So
Yeah.
in this model,
yeah.
in this biblical model, we have all the contents not starting at a single point, but instead starting apart from each other and actually manifesting in
Exactly.
space. So, and then beyond that, you have, all right, man, beyond that, you have the light of the stars already reaching the Earth. So you have light being created already in transit. All right. So now what does that tell us? Like, are we getting a live feed then? I don't know. Probably not. I mean, we're told that we're looking back, millions, even billions of years into the past by staring up into the heavens. That's what they're telling us.
Well, that's the
So is
presumption,
it really a distant starlight problem though to begin with? Because the way that they're measuring the distances to these stars with stellar parallax, basically triangulation from either side of the sun from the Earth, we're measuring to these bodies out in space. But you can only do that accurately, and they claim 400 light years. 400 light years, not millions.
No. You can't triangulate this stuff. No, it's just too big.
Well, we can't, but our astronomers can, because what they're doing is they're triangulating these stars that are close to Earth by measuring where they are in the sky, pinpointing where they are in the sky when we're on either side of the sun. So in the time of the year when it's at the correct spot in the sky, we took
I get it.
and then we waited, and then we wait half a year. But
I understand how that works. It works really well for planets, but it works. But what I was saying is that it can't work for most stars. There's not that many stars that are 400 million light years away. Most of them are way. 400 light years. Sorry. Yeah. No, 400 light years. Yeah. There's.
And it's like you'll believe that the universe is 400 light years old, right? If that's really we're seeing back in time, you can accept 400 years. But that's the furthest we can measure accurately with the stellar parallax method. There's also the luminosity.
Are you talking about 4 billion? Oh,
no, I'm talking about 400. 400. I say that it's not even 400. What I say is it's not even 400. It's much less than that. If you want to be accurate, if you want to be able to measure, because what you're doing is you're like on either side of the sun, and you got to think this is your triangulation points. Once you go past 27 light years, it's like you're guessing, because your triangulation. The triangulation of your lines are going out into space so far, it basically becomes a straight line. So triangulation becomes useless. So then they move to what's called testing luminosity or whatever, or luminous or the frequency of a star, okay, in these galaxies. So once you
And
get
that
out
comes
far
with
enough,
a
and you're
million, and
looking
that
at
comes with a lot of
galaxies,
presumptions.
it
If
is.
they were
It's,
100
they're guessing, and that's the whole point.
Let's
Like
let
the
Jason
they
talk.
were
He's
distance
driving
of
me.
these
He's
bodies
driving
is
me
immense.
nuts. I don't know what he's saying.
if
Jason,
they
what
were
are you talking
hundreds
about?
times out, if they were hundreds of times out, say their guesses for 13 billion or 14 billion, even if they were hundreds of times out, it's still like within the region, you know what I mean? Of realm
No,
of
no, but we're talking
possibility.
about something different, Jason. We're talking about something completely different.
Sorry.
You're missing it. Yeah.
Wait, what are we talking about?
Go ahead. Go ahead. See science. He just didn't know. We were talking about the stars that we can triangulate.
Right.
Triangulations. Different topic,
Now
Jason.
he knows
Right.
this. Now Jason
Talking
knows
about
this, that
distance. No,
triangulation
but
only
you're
works so
talking about
well. So.
distance, right? You're talking about the distance that
Right.
we can't. Yes, that's right. You're talking about the distance. Even if they were hundreds of times out, say they were 300 times out, it would still not account for the distance they can see, sort of thing. Is I think getting it wrong in that sense. They can actually see those distances where you say they can't. I believe they can. But anyway, so
Well, that's another measurement system. We were talking about a specific kind.
Yeah. Well, what I'm trying to say is it's an estimation. What they're doing is they don't know the actual distance. As far as triangulation goes, the stellar parallax method, they can only measure out 400 light years, and that's what they're claiming accurately. I'm saying it's much less than this, because once you have these two lines going out into space from other side of the sun, from our planet, supposedly we're measuring these distances. If you go on beyond 27 light years, you're basically looking at a straight line. It's no longer a triangle. You dig what I mean? Because you're only looking from either side of the distance from either side of the earth is one side of the triangle. Yeah. So beyond that, they have to use a different method to measure or estimate the distance to these galaxies.
So I want to briefly talk about. So I see little things in the Bible. It's amazing to me how much predictive power the Bible has, and the descriptions of the universe. Over and over again, I talk about it. I won't go into it too much, but when it comes to microwave background radiation, simply how no matter what direction we look into space with that type of metric, it's just like this consistent utterance that's kind of pretty much the same everywhere you look. And it's interesting you pattern this with scripture, because it talks about how the stars sing together, and the specific word for sing is like, in this case, a uniform moaning together. Like and it says, scripture talks about how it's day unto day, night unto night, they utter speech together. The stars do this to teach us things. This is specifically what we spend these trillions of dollars on, building these giant telescopes, and all, supposedly to listen to, life out there in the universe that would be sending signals, but all we hear is just this uttering. This seems to be relatively almost equal, no matter where we look. And it doesn't matter if it's nighttime or daytime, right? Because it's the same. It's the same fuzziness that you see on those old TVs with the black and the white. That's the same frequency or whatever. It's basically the same stuff that you're picking up with the big telescopes. But I just find it interesting because
as soon as you finished with that talk,
that was it. Yeah.
Can we watch that while after?
But real quick though, see what do you think about that?
I'm sorry, man. I was writing in the chat really quick.
Can
you summarize the question again?
I was just talking about how the description of stars.
Sorry, man.
I was talking about how the description of the stars in scripture.
Oh, how they sing together. Yeah, I mean, that's interesting.
How they sing. Yeah. So it's day unto day, night unto night, the utter speech, to reveal knowledge,
Me,
how it's consistent with what
everyone
we
else.
observe here. Right? Go
So
ahead.
you're
What-
saying
what's
like
the-
that the
I see a lot of
sound
this.
from the cosmic microwave background could be that humming or that singing, basically.
Yeah, if you look into the specific words that in the Hebrew,
Sure.
it's
That's an
literally
interesting
like
interpretation.
very similar to what we observe, and it doesn't have to be daylight; it can be night. Like it's because it's just always there, and it's
Sure.
from
I'll tell you what
creation.
stands out to me the most in the scripture as far as that is
There's a-
how it says that he stretcheth out the heavens, which means that he's
Oh, yeah.
continuing to do it because it's the present tense, infinitive tense, And you're like,
Mhm.
it's like he's continuing to stretch out the heavens. So, and that's exactly what science has shown. That's what cosmology and observing through and astronomy has shown us, is that the heavens are being stretched out, much like a tent to live in.
Dude, they and the curtain
It's so accurate.
and a garment. But get this, they even use the same words from the Bible now. The fabric of space, literally what the Bible says. Follow me?
That's true.
The number of connections that I've made concerning just the stars is insane. Think about how they all differ from glory to glory. So think about it. Now we can see it. They couldn't before. Think about the number of them. God describes them as being uncountable, right? But not infinite, but uncountable. And then they used to argue about them only being like 1,500 because that's all you can see until you have telescopes. So just continually throughout time, science has vindicated, glorified God and what He said in hundreds of ways, just with the stars. But anyway, with that, I'm gonna rest my
Yeah. Danny Faulkner is a theistic evolutionist. And this is what he says. It's interesting. I like to get both sides of the argument.
Yeah.
And this is what he says about starlight. It's interesting. He talks about how they measure it and that.
Well, we've had a shift here, and we got the autumn stars high overhead. One of them is back behind me here. We have this M group of stars in the sky. Earlier it was a W.
That's true.
But now it's an M, and that's because the rotation of the Earth has caused the whole
Wait,
sky
wait,
to
hold on a second.
wheel
This
around
guy's
the
not
North
a-
Star.
this guy's not an
And as it does,
evolutionist.
It changes
I
from
was
the
gonna say.
rather than the back half.
Yeah.
That's the constellation of Castor.
No, he's a theistic evolutionist.
He's not an evolutionist though. Faulkner's not, right? I love the guy. I heard you, but he doesn't actually believe in evolution though, right?
No, he's
In terms of
I know,
animals.
but he's a theistic evolutionist, not a.
I
No,
guess you don't know what the term theistic evolutionist is, Jason.
Yes, theistic. He's a theist who believes that God used evolution. Okay.
No, but I'm asking my question. Does he actually believe in like biological evolution? I don't think he does.
He believes that God used evolution. Like he's one of those Christians.
I don't
who
think he
believe-
is.
Okay.
think
Well,
Faulkner is.
anyway, let's let him talk now and just see what he says. All right.
We'll hear it from the horse's
Cassiopeia,
mouth
the
here.
queen. You're supposed to see a queen seated there. I don't really see that. And then back this way a little ways, we have the Great Square of Pegasus. It's this big rectangle,
I see that.
not quite a square, but we call it a square.
Uh-huh.
There are very few stars inside, so it really jumps out at you.
Yes.
High overhead in autumn evenings, and it's supposed to be a winged horse. This is the body of the horse and the wings sticking out here. Its head is up here like that, and out here the two front legs.
All
We
right.
only have the front half. We don't have the back half. But I've always thought if you're going to have a half a horse,
You better have the front half.
front half rather than the back half.
Yeah.
That's the constellation of Pegasus. Now, coming off of Pegasus is Andromeda, supposed to be a chained maiden here. Go up a couple stars, there's a little fuzzy spot right there.
I
Do you see that?
Yes, I
Now,
do.
it's best to use averted vision. You don't look right at it, but you
You
look off to the side.
Mhm.
And when you do that, it shows up much better. A little fuzzy patch.
Little fuzzy spot.
That's the Andromeda Galaxy. That is the most distant
Oh.
object that you can see with the naked eye. But it's the nearest galaxy, similar to our own galaxy. We think a little over 2 million light years away, and it contains a couple 100 billion stars.
Wow.
So it's a very impressive object in the sky, but you need a lot of aperture to see it well.
Yeah. Okay, Danny, that brings me to a big question, and a big question in a lot of people's minds. If we have stars that are that far away, millions of light years away, and if the Earth is young, as we believe, then how in the world can the starlight be here?
Yeah, we call this the light travel time problem, and I'll try to phrase it for you a little differently. We believe that the creation is only thousands of years old, say 6,000 years, 7,000 years, something like that.
Mhm.
And I've just pointed out something to you that we think is 2 million light
Yes.
years away from us.
Right.
I think those distances are reasonably correct. You know, if that's off by 100%, that's still maybe 1 million light
Sure.
years. So
Right.
that isn't going to solve the problem.
Mhm.
And by the way, this is just the closest. There are galaxies that are hundreds of millions, even billions of light years away from us. So the question is, as you ask, if the universe is only 6,000 years old, you can only see things within 6,000 light years. How can we see those distant objects?
Sure.
Now, it wouldn't affect most of the stars we see because they're at most a few hundred light years in most cases, or a couple thousand light years. But you know, the situation, Del, is a lot worse than you said. The situation is even worse. Let's go back to the beginning of creation. Say at the end of day 6, beginning of day 7, the sky gets dark.
Yes.
The creation's ended. Adam and Eve look up, the sun sets, the sky gets dark. What do they see? They had to see stars, because
Yes.
if they didn't, the stars could not fulfill their function. But the
Mhm.
problem is the nearest star outside of the sun is more than 4 light years away. So how could Adam see the nearest stars? We're so concentrated on the most distant objects in
Sure.
the universe, but we really need to think about what
Mhm.
Adam saw in the closest objects outside
Right.
the solar system. If you can answer that question, that problem, then I think the problem we have today is probably answers
I
itself.
see that. I see that.
And we creationists need to answer this question, and we've offered several different solutions to that. I'll discuss with you my solution
Okay.
on this. And I came up with this a few years ago after wrestling with this for years. And I think I was looking for a scientific answer, if you will, a physical answer. But I think several things jump out at me in the creation account. One is that many people think that everything during the creation week was instantaneous. Poof, a tree appeared where there was none. Poof, a whale appears where there was none. But that's not what the text generally says. There's a lot of process going on, very rapid process, but still process. For instance, did God make Adam just poof out of nothing? Well, no, he shaped his body out of dust of
Right.
the ground. What about Eve? Well, he took from his side and
Mhm.
made Eve. That was a process in either case. It was a quick one. It didn't take, hours or
Mhm.
days. It happened less than a day.
But it
But
was a
It
process.
still was a process. If you look at the count of the animals, not on the chapter 1, but in chapter 2, it speaks of the animals coming out of the ground giving rise to these things. If you look at the day 3 account, it talks about plants rising up out of the ground. It says, let the earth bring forth these plants, and the earth brought forth. If you look at those words used there in Hebrew, they're very active, dynamic terms. It's almost like these things are sprouting up out of the ground very rapidly. I think if you would have been there, it would have looked like a time-lapse movie. You would have seen growth that might take normally decades taking place in a matter of minutes or hours at the most. Normal growth abnormally fast. Why? Well, in another 2 to 3 days, you can have all sorts of critters and people that are going to rely upon those plants, because it turns out everybody was vegetarian to start with. And if you waited till they normally matured the way they normally do, everybody would have starved. Because, even the fastest growing garden plants take a couple of months to reach maturity. So God had to mature these things fast, rapidly. He didn't make them mature. He matured them rapidly from what the language is telling you there. I believe you can interpret one day of creation in terms of another day. So I turn to the day 4 account. Not much information is given there, but I think God also rapidly made the stars and other astronomical bodies. And then in order for them to fulfill their function to be seen, he had to rapidly bring forth that light, just as he brought plants and matured them quickly. He had to bring that light here. Now, I'm not suggesting the light was created in transit. That's one theory. You see, if you have light created in transit, the light
That's
we're
my
getting
theory,
from these
by the
distant
way.
objects didn't come from physical processes. It's like they were holograms.
Problem with that is that we saw a supernova event in the 1800s or something like that, and it was like so many hundreds of light years or thousands of light years away that or so many thousands, that's right, it was way past the beginning of creation, so we shouldn't have actually seen that. So unless God is creating light in transit constantly, anyway, so here we go.
Or
Yes.
just illusions. I'm
Mhm.
suggesting when we actually look at these objects, like the Andromeda Galaxy we saw a few minutes ago, we're looking at light that actually left that object.
Yes.
I believe
see.
that the Andromeda Galaxy is about 2 million light years away, but I don't
Mhm.
for a minute think that the light has been traveling that long. I
Mhm.
think we're looking at the universe in something close to real time. If the light's only a few thousand years old instead of a couple of million years old,
Mhm.
well, that's pretty
Mhm.
close to real
Sure.
time.
Yeah.
So I think there's a rapid maturing took
Yeah.
place.
Huh.
Also, I'm not appealing to a physical mechanism. I'm appealing to a miraculous.
Sure.
And some of my
Mhm.
creation science buddies have given me a little bit of grief on this because they're looking for scientific answers for everything. And you can give scientific answers so far back. But you know, the writer of Hebrews and also Paul writing to the Colossians talked about the current sustaining of this world by the power of his word.
Mhm.
Moment by moment, the Lord sustains this world. I don't know how he does it, but maybe it's miraculous, but he does it in a consistent pattern, the way that God
Mhm.
does things. He does them consistently and orderly. And we can study that. In fact, we can write equations that describe it. These equations we have, it's called physics.
Mhm.
And so the study of physics is really the study of how the world is being sustained moment by moment.
Mhm.
But you can't take that sustaining and extrapolate it back into the past because eventually you'll bump up against creation
Mhm.
in the past. And creation is a miracle.
Mhm.
There's a certain point where the miraculous take place. And I think at some point, maybe it's stages, but certainly by the end of the creation week, God went from creating to sustaining.
Mhm.
And if we try to push back the current sustaining, what we call physics, into the creation week too far, we're kind of committing
Sure.
the uniformitarian assumption. We
Sure.
we accuse
That's
the
right.
evolutionists of. And I think sometimes we seriously underestimate how the miracle of creation. We might as well come up with the physical
Mhm.
explanation for the virgin birth and the resurrection.
Right. Yeah.
So you know, after more than 3 decades of wrestling with this issue, I finally come to peace with an explanation. And it's
Uh-huh.
interesting that a scientist has come around with an appeal
Yeah.
to a miracle. And I'm okay with that. And I found many people are okay with
Yeah.
that.
Well, Danny, this all makes sense to me. In fact, it even reminds me of the first miracle of Jesus. And if we were to try and take physics and all that we know about wine and try to understand how Jesus created wine in a very rapid moment, we wouldn't be able to do that.
No, and I think that underscores the fact that that science addresses the natural world, and
Mhm.
miracles are supernatural.
Yeah.
And so you can't use a scientific method to discuss miracles. I
Yeah.
don't think.
Well, Danny, do you see any other evidences that would indicate that the universe is really much younger than what the traditional paradigm would tell us?
Yes, I do. For instance, spiral galaxies. The Andromeda Galaxy we talked about is a spiral
Yes.
galaxy. Our own is. It's a pretty common type of galaxy. In their disks, they have this spiral pattern made up of clouds of dust and gas and bright stars. And the inside of the galaxies should spin faster than the outside of the galaxy. So after a few rotations, you ought to wind up or smear out those spiral patterns. They ought to disappear after a few rotations. Now, most astronomers think that spiral galaxies are 10 billion years old. So why do we still see spiral patterns? You
Mhm.
shouldn't see those.
Right.
And it's
Yeah.
been a long recognized as a problem. In the late 60s, they developed this thing called spiral density wave theory, and that was the answer for several decades. That they assured us that it worked, that there were these sound waves propagating through the galaxy that made these things persist. Well, then by the 90s, they were invoking companion galaxies that were stirring things up instead. And more recently, it's now been dark matter that's stirring these things up. So we've had, in the last 45 years, 3 different solutions to this problem. You don't need new solutions if the old ones worked, and they assured us that they did. So I think that's a problem.
Yeah.
If we look at the outer planets of the solar system, the gas giants, they all have rings. You know, when we were growing up, only Saturn had a ring system,
Yeah.
but now we know that the other 3 have them as well. And we also know that these things are changing, wiping out. We know theoretically they ought to, and with probes to Saturn and Jupiter, they've actually documented changes that have taken place within the ring system. You have all these gravitational tugs from the other satellites orbiting around. And people have estimated that a ring system like Saturn's can last maybe 1 million years or just a few million years with an M, not a B. So these ring systems are fairly young. Doesn't prove the solar system is young, but it proves that these
yes.
ring systems are young,
Mhm.
and that's interesting.
Yeah.
You know, in the summer of 2015, we got the first photos from the surface of Pluto, and the big shock everyone had, including me, was the fact that there's a lack of craters. There are a few impact craters, but not many on Pluto. Now, it's been doctrine for decades in the solar system that wherever you see lots of impact craters, it indicates a very old surface. And when you see
Mhm.
very few craters, it's a young surface. You've had geological activity that's reworked it. And you can do that 3 different ways. Well, no,
So they just say that that the surface of Pluto is got some geological activity below the surface, which is like filling up these meteor craters with ice. But then they have to explain why Pluto still has geological activity when in their model it shouldn't have any at all. It should be cold, dead, and dark. Basically, that's what he's. I don't know if he gets to that. I can't remember. Hang on a second.
none of them work for Pluto.
Hmm.
So it indicates that Pluto is a young object.
Uh-huh.
It doesn't have any way to do this. Now they're trying to figure that out. How in the world in billions of years you can have a young looking
Yeah.
Pluto?
Hmm.
Those are the kind of little interesting things that you see from time to time about the planets. We see evidence of rapid processes on the surfaces of planets. Venus, they believe, had a complete overturning of its surface in the not too distant past. They say like 150 million years ago, which is pretty recent in a 4.5
Sure.
billion year history. But they think the entire surface of Venus was turned over in a very brief period of time, million years or less on their time scale. Furthermore, you look at Mars. Secular scientists are saying that there was a global or near global flood on Mars, a place where there is no water today.
Well, I just want to tell people straight away. I hope I'm coming through.
Yeah, I hear you good.
I just want to tell people with this Mars thing that I saw a photo of a section of Mars, and then it showed like Mars in a global dust storm, and then it showed the same section after the global dust storm. And if anyone was looking at the formations, they would say they were formed by water. Now, what you got to remember is that if you get a tiny little insect flying through the air that we're flying through, if you watch it from their level on a macro camera, it looks like they're flying through liquid, right? So basically air, and if there's air there or something to blow around or some sort of air atmosphere, it's like a liquid, right? So it's depositing these sand layers and stuff like that and making it look like liquid, because after this massive global dust storm, you just would have sworn it was laid down by liquid. So when they believe in a global flood on Mars because they've got all these water formations that they say across the planet, then you can see where their thinking on that might be a bit flawed.
Yeah, and I mean, you know, like for young Earth creationists, usually these geological layers on Mars is an issue. I mean, even if they were made by water, I mean, you still have 6,000 years of time for a lot of things to happen. A whole lot can happen in 6,000 years. So we don't know the history of the cosmos because we don't have a time machine. It's my opinion. Yeah, I mean, it's my opinion that God created all the universe and its contents with a given age. You know, I believe that's biblical. I think he made the trees with fruit on them for Adam to eat, and I think he made Adam as an adult, and I think he made adult stars, if there is such a thing. But he made the stars as they are now, 6,000 years ago. You know, he made a universe to be lived in. So,
yeah.
And it makes sense to me that, like you said, with the dust storms that they have on Mars, that this could also form geological layers. Obviously, I mean, if it's really just a desert area,
Look like water. that look like
Oh yeah, it would
water.
look just like water because it'd be several storms, layers lay on top of each other. It'd look just like it, especially with those cameras that they've got on the rovers that they're sending back. So,
yeah, well, I saw like one from outer space before a dust storm, and they focused in on one section of Mars, like a large part of Mars. And then they showed the whole of the planet in this massive dust storm, and then they showed the same section after the dust storm, and it looked very different, like almost completely different, and with all these massive weird formations, like water-looking formations and stuff, and it was all created from this dust storm. So when they say that they see these massive canyons that have been etched out by water and stuff, well, what do you think about those canyons being etched out by water when you hear about what I just said? And
yeah, I mean, it could have been air, and it could have been the wind carving all this out. But even if there was water on Mars at one time, that leads to the question: where did it all go?
And you got to remember that wind,
especially if there's a global flood on Mars,
like a sandblaster. It's acting like it's cutting. It'll be cutting like water, does with massive amounts of. Anyway, so you guys want to talk on about this while I get my dog out to the toilet?
Yeah, or you could just let it play on, brother. What do you think, Pizza? Play on. I think he might have fallen asleep or something. So.
Okay. No, I'm multitasking here.
All right, no problem. Play on, sir.
They don't think that could have happened on Earth because, well, they don't believe it happened, but there's plenty of water here. Those are the kind of things indicating rapid processes, much more rapid than many people realize. So I think there is evidence out there. And my job as a creation scientist, as an astronomer, is to identify and discuss those and bring attention to them. And I intend to keep doing that over the years.
Sure. That brings us to what most people see as the big theory concerning cosmology and the universe, and that's the Big Bang. How do you see that? Is it holding up over time?
I don't think so. I think it's getting some problems. I reject it because I'm a biblical creationist, and I don't see any way that you can reconcile Big Bang with the Bible, though a lot of people seem to think that you can. I think the temptation they have there is to try to interpret Scripture in terms of the current cosmological thinking. That's nothing new. That's happened before, as it's turned out, with disastrous results. But I like to compare the Big Bang model to the ruling cosmology of the Middle Ages, what we call the Ptolemaic theory. A man named Claudius Ptolemy around the early 2nd century AD developed this theory to explain the motions of the planets. As the planets orbit around the sun, and we orbit around the sun too, it makes for a very complex motion. The planets, as well as the sun and the moon, seem to move in a west-east direction along the ecliptic, the plane of the Earth's orbit around the sun and solar system, actually the plane of the solar system. But from time to time, the planets reverse direction. They go from west to east, back to east to west. We call it retrograde motion. And that was difficult to explain if you think the Earth is the center of things, the geocentric theory like the ancients did. So what Ptolemy came up with is this very complex model where you had a planet not just orbiting around the Earth, but you had it orbiting on a smaller circle we call the epicycle. And the epicycle in turn went around the Earth. And if you adjust the sizes of those two circles and the speeds, you can end up with this motion like this where the planet seems to move backwards. And this was the ruling cosmology for 15 centuries, from really the 2nd century up through the 17th century. Now, as new data came along and problems developed so that you had a discrepancy between the theory and the data, they simply altered the theory, added more epicycles to make the theory work and fit. That was the strength of the model, that you could adjust it to fit anything new that came along. Well, there was also the undoing because it became very complicated. By the year 1600, there were systems of more than 100 epicycles. You had gears on gears on gears on gears, and people realized this is way too complex, and finally it was rejected. And the Big Bang has done the same thing. It's been the ruling paradigm for 50 years. And in that length of time, I've seen tremendous changes take place. In the early 1980s, we had this Big Bang model that seemed pretty mature, and they were convinced that this Big Bang model was true. But since then, a lot of changes have taken place. They changed the expansion rate of the universe, which decreased the age from 16 to 18 billion years to 13.8 billion plus or minus 1%. They've introduced string theory, into the model.
Mm.
This is a thing dealing with particle physics you have to put in. They've introduced dark matter. They've introduced dark energy. They've introduced this idea of cosmic inflation, that the universe expanded very rapidly in the early universe to solve a couple of problems that they have. By the way, there's no evidence for inflation, but everybody believes it happened because basically we're here, aren't we? I've seen in my adult lifetime numerous changes taking place to the Big Bang Theory. And it's starting to look like epicycles. It's starting to look like the Ptolemaic model, just as the strength of that model was that you could change it to fit new problems in data. They're doing the same thing with the Big Bang and changing it. You know, they had the COBE experiment in 1989 to 91 that was measuring little fluctuations in temperature predicted in the background radiation, the supposed proof of the Big Bang. And they had predicted fluctuations in temperature and from point to point, 1 part in 10,000. Well, they found fluctuations 1 part in 100,000, a factor of 10 less. And afterwards, they said that the predictions and the actual measurements beautifully agreed. Saying, wait a minute, how can that be? What they did is they changed the model to fit the data once again. You know, if you have rules like that, you can never disprove a theory. One of the fundamental assumptions that the Big Bang is based upon is that there's homogeneity of the universe, that it's kind of smooth. It makes the mathematics work out easier, by the way. And we recognize that on the local level, it's kind of clumpy. We have planets and stars and so forth, but then you have galaxies, and then you have groups of galaxies and galaxies working their way up. And it's kind of assumed that on the biggest scale that sort of smooths out. But what we found over the last 35 years is that this clumpiness goes up to the highest levels. Kind of shocking when they begin to realize that. They don't talk about it much anymore. But the problem is we're now really poised to make what we think is the structure of the universe on the grandest scales, and it's clumpy all the way up. And what most people have failed to realize is this negates the very foundation upon which the Big Bang is based. The assumption of homogeneity. It's not homogeneous anywhere. It's been an article of faith that at some level it is homogeneous, despite all evidence to the contrary. And we're seeing it on the giga light year scale now. It's across the entire universe. And so the Big Bang has become the ruling paradigm, and it's becoming doctrine. It's becoming dogma. So much so that more than a dozen years ago, I think in the New Scientist magazine, there was an open letter protesting the Big Bang Theory, and it's had hundreds of signatories since. And most of the people signing it are atheists. They're not even creationists. So this idea that the Big Bang model is universally accepted is not true. There are many people out there, well-known people, very famous physics and astronomy people, that have real problems with the Big Bang. So I think when you look at the history of science, the way we've discarded theories over time, you've had theories that were supposedly beyond dispute, and then later on discarded. When you see that lesson from history, and then you want to wed Genesis, you want to interpret Genesis in terms of the ruling paradigm, I think you need to be very careful.
Sure. Yeah. Well, all of this, Danny, just brings me back again to the awe associated with.
Yeah, good stuff.
We're the only ones left. Hey, how about we go back to this one, all right, the cosmic inflation one. That's
sure.
That one's actually very interesting. I like that one, and we still got the same spot too. So,
I think Gum asked a pretty good question here, Jason. We should answer, if you don't mind. He asked, do Christians think the universe is eternal? What would your answer be?
I mean, no. The universe is created. God's eternal. Eternity that God lives in is eternal. We can't imagine what that's like. We don't know why God's from everlasting to everlasting. You guys don't know why your eternal matter and energy is from everlasting to everlasting. It's eternal, so it has to be the same. So it's the same sort of question back at you. Anyway.
You know what I wondered is if time is eternal. Like, how much of this universe is eternal? Like, I mean, maybe the physical constants aren't, Well, they'd have to be if time is eternal, though. I don't know.
You know,
I
time
haven't
was
thought enough about it
created.
enough, I guess. Yeah.
Time was created by God, so time is something that he can do whatever he wants with, I suppose. He's like I suppose, I always used to say, not always used to say, but for a long time I've said that the Time Lord from Doctor Who is like God. You know what I mean?
There you
He
go.
created time. Go anywhere, do anything he wants with it whenever he wants. I'm not saying God goes through time and does things because he doesn't need to, because he's infinitely intelligent. He doesn't need to be like the Doctor Who. He would have set it all up, which way ever. He would. What I mean is, he would have kicked it off and started it, and then seen what we did with it afterwards, all the way through. I believe if you're infinitely intelligent, you could literally give everyone free will, and then just see what they did with it through time. And then if you had like prophets and that, you could let your prophets see visions of what you saw. We did with it. So, and if the prophet saw those visions, the prophet could say accurately what happened, because if the prophet was even a little bit off, they got stoned to death.
So that's a good answer. So you'd say God is eternal, but probably the universe and the contents of it aren't. So you invented those. So
yeah,
and I'd say we
Yes.
agree on that. We definitely agree on that point. Even if we don't agree on the distant starlight problem or how we answer that problem, we definitely agree on that. God is eternal, and this universe and its contents are his creation. So another good question is, see, I heard that some Christians think Jesus will come and rule down here on the earth. What do you think of that, Jason? The millennial reign, I think is.
Yeah, I don't know much about that, and
Okay.
I don't really care. Like either way, I mean, I really, if what I mean is if if there was some sort of like system to anything, if I was the doormat that people wipe their feet on as they walk into the new creation, mate, I'd be happy to be that doormat. So I don't really care, whether there's 1,000-year reign, whether Jesus Christ is going to be, whatever. I just couldn't give a flying fuck. I mean, honestly, I
Well,
couldn't care less.
do you think it would be here in this life, like on this? Oh, obviously on this earth, but I mean, this would be. Would this be before Armageddon or after?
We get into the realm of there's going to be a new heaven and a new earth. What does that mean? I mean,
sure,
and stuff like that. So it's
which is
like,
hard to interpret, because there's several interpretations of that. What new heaven and new earth might mean.
So. There'd be as many interpretations and opinions about that as there are people on earth, but it's just.
It moves into conjecture in a gray area that really the Bible doesn't. I don't know if the Bible really reveals. I guess it'd be.
Doesn't.
I don't know. I mean,
really
I guess.
Matter.
Well, I guess no, it wouldn't be Revelation. I guess Revelation would be the book to look at, and you'd be looking for the millennial reign of Christ, is what it would be. Because they say that there's supposed to be a ruler that lives 1,000 years here with us, and he's our king and rules with an iron rod. That would be Jesus, or the branch of David, which is prophesied of in the Old Testament and book of Isaiah. So, yeah. He also asks if Jesus is providing his flock eternal life. Sorry, they will also an eternal kingdom and universe. So yeah, I mean, yeah, that makes sense. If we're going to have eternal life, obviously the place we're going to be is going to be eternal. I mean,
yeah, it's
and they say that our cosmos isn't eternal. They say that it's cooling off. The whole thermodynamics, the whole concept of that, like the whole universe is eventually going to fizzle out and all these stars will burn out. And, I guess, so this one couldn't be eternal anyway. So, yeah, I guess it makes sense. So we would need a new heaven and a new earth. Probably, I don't know. I don't want to say that's what it was like or meant to be in the beginning, but, I mean, it's definitely the plan, it seems. So
who knows? But anyway, so let's just get back to what this guy's saying for a sec, because I've got to do a couple of things, and while he's talking, and anyway.
Galilei wouldn't have needed to have demonstrated that two objects will still have the exact same accelerative force when dropped upon the same distance. That was not something that was necessarily intuitive to people. For many, 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 many years, people thought that if two objects had different masses, that the heavier mass would drop faster. There's many different things in science which are not necessarily intuitive. Space-time is a great example of something that is not intuitive. That does not mean that it does not exist. So with that being said, I would be happy for Kent to, highlight actual specific parts of cosmology, or Big Bang cosmology specifically, that he is incredulous towards. I'd be happy for that to be the case, and I'd be happy to address them. But it's a little bit difficult when it's all laid out in one big plethora or all big batch of things, just with the umbrella, the umbrella theme of which all being, well, I'm just incredulous of this concept. So please, with that being said, Kent, go ahead. I'm sure you're going to be given 10 minutes. I could even give you the balance of my time on top of your 10 minutes. Please go ahead.
You have only taken 5 of your 10 minutes, Aiden. Are you sure you want to relinquish the whole 5, or I can hand it over to Doc now? Okay, Dr. Hovind, it's back to you. You have 10 minutes, sir.
Okay, well, let's see.
Actually, there's just, I went on to the wrong one then. And while I was in the wrong one, I found the right one that I wanted to, this one. I wanted to keep going on with this one.
Of the horizon problem. Like, how do you get the universe to be roughly the same temperature everywhere you look, even though that's not what the Big Bang model predicts? Well, here's what they say. According to the NASA website, they say inflation supposes a burst of exponential expansion in the early universe, so it follows that distant regions were actually much closer together prior to inflation than they would have been with only standard Big Bang expansion. Thus, such regions could have been in causal contact prior to inflation and could have attained a uniform temperature. Now, I don't know about you, but I'm getting ready to bring out Beaker again because I'm kind of feeling like that. I'm a very visual person. If I can't see it, if I can't touch it, then I have a hard time understanding it. So I'm going to bring up a picture here. And this is what is said that the Big Bang is supposed to look like. So over here on the right side of our image, we have where we are today. And as you can see, there's some people right here. I guess that's us. And when we look into outer space, we look from the right of this diagram all the way back into the left. And you see this right here, this third disk from the right, this colored one right here. This is where the cosmic microwave background radiation is. Remember the false color map that I put up here earlier? That's what we're looking at right there. And the distance between that and the Big Bang is 3 times 10 to the 5 years, or 300,000 years. So there's supposed to be 300,000 years. I bet you don't see many people who can do this, right, Chris? 300,000 years between this disk right here and the Big Bang. Well, where's this inflation going on? Well, on the left here, you can see, maybe you can see this as Big Bang. And then here you can see that the slope of the expansion of the universe is pretty shallow. But then suddenly it kind of kicks into high gear right here, and this is the period of inflation. So the idea behind inflation is that the Big Bang happens, and then a lot of all the temperature exchange that they need to happen between all the globs of matter happens at this point, and then for no apparent reason, the acceleration rapidly increases, and then again, for no apparent reason, the acceleration stops, and the expansion resumes its leisurely course out here. So this is what cosmic inflation, this guy right here, is what is supposed to solve the Big Bang's temperature problem when we get all the way up here to the cosmic microwave background radiation. So a lot of people, when they look at this even, they kind of look at this and they go, okay, lots of technical mumbo jumbo, wah, 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 kind of like Charlie Brown's teacher, right? I imagine some people are kind of like this. Now, we don't have sound here, so I'm going to have to narrate for you. This is from the movie The Naked Gun. So here we go. And he comes up here and he says, all right, nothing to see here. Please disperse. Nothing to see here. Please disperse. Right? Meanwhile, there's a fireworks factory on fire behind him. There's nothing to see here. Cosmic inflation solves all the problems. Everybody move along. Go about your business, citizens. But the problem is that, well, that's not really the case. You see, inflation, cosmic inflation, has problems. It has big problems. Take this quote, for example. This guy says, does the theory really work as advertised? Are the predictions made in the early 1980s still the predictions of the inflationary model as we understand it today? There is an argument to be made that the answer to both questions is no. Okay, pop quiz time. Guess who said this? And I'll give you a hint. It ain't Ken Ham. The guy who said this was none other than Paul J. Steinhardt, the director of the Princeton Center for Theoretical Science. Do you recognize that photo? About 4 slides ago, I showed he was the guy in the middle, one of the originators of the cosmic inflation model, cosmic inflation theory. He said in another article that I read, somebody asked him, well, when did you start having doubts? Paul Steinhardt has been one of the harshest critics, the most vocal critics of cosmic inflation over the course of the years. A lot of people don't talk about this. And these quotes, I'm pretty sure I got the article from Scientific American. So it's not like it's buried out there. It's out there, but people don't really talk about this. In another article that he co-wrote with 2 other scientists, Steinhardt says, yet even now, the cosmology community has not taken a cold, honest look at the Big Bang inflationary theory or paid significant attention to critics who question whether inflation happened. Rather, cosmologists appear to accept at face value the proponent's assertion that we must believe the inflationary theory because it offers the only simple explanation of the observed features of the universe. He goes on to say, inflationary cosmology, as we currently understand it, cannot be evaluated using the scientific method. As we have discussed, the expected outcome of inflation can easily change if we vary the initial conditions, change the shape of the inflationary density curve, or simply note that it leads to eternal inflation and a multi-mess. That's what Steinhardt calls the multiverse theory. He calls it a multi-mess because that's what it turns into. Finally, he concludes with, individually and collectively, these features make inflation so flexible that no experiment can ever disprove it. One of the 3 pioneers of cosmic inflation telling us it's not scientifically verifiable, it's not a scientific theory, really. It's not testable. And no experiment can ever prove it. It's a solution that solves every problem. All they have to do is turn the dials, flip the switches a little bit, and boom, it solves the problem. So here's the thing to walk away from with this little section of slides. Cosmic inflation is not settled science. Matter of fact, I would caution you that if anybody ever uses the phrase settled science on you, you should look at them suspiciously and ask them, I'm sorry, do you actually understand how science works? Because there's no such thing as settled science. Science is never settled. You see, science, and by science I mean the scientific method, scientific inquiry, is inductive by nature. And what that means is we take little points of data and then we try to extrapolate that out and figure out a theory that describes what's going on here. But the interesting thing about inductive reasoning is you're only ever one discovery away from having your pet theory invalidated. Only ever one. So science does not deal with certainties. Science does not deal with absolutes. Science deals with probabilities. You either have a theory that is strongly correlates to the evidence or you have one that weakly correlates. But you do not have one that proves anything. And please, 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 I see this all the time on Facebook. Please never say science proves the Bible or science disproves the Bible. To do so is to put science on a higher authority than the Bible, to sit in judgment over it. We don't sit in judgment on God's word. God's word judges science. Okay, sermon's over. Let's get back to this. Let's get back to this. So cosmic inflation is not settled science. There's no such thing as settled science. And to illustrate the point, one of my favorite movies was, I think it's the 1991 movie, Men in Black. So Tommy Lee Jones and Will Smith are the main characters in this film. And Tommy Lee Jones is this wizened, he's part of the Men in Black. And what they do is they police the alien activity, extraterrestrial alien activity on the Earth. They keep track of everybody, kind of like INS on steroids. And so he's looking for a new recruit, and he finds Will Smith, and he's trying to recruit him into be one of the Men in Black. And he takes him into this pawn shop, and Will Smith has his first encounter with a real live space alien, and it just blows his mind. Right? He's completely blown away. So the scene cuts, and Will Smith and Tommy Lee Jones are sitting on a park bench in New York City, and they're just trying to take this all in. And Will Smith says, well, why all this secrecy? People are smart. Why don't you just tell them what's going on? And Tommy Lee Jones says, no. A person is smart. People are dumb, panicky animals, and you know it. And then he picks up with the rest of this, which I will also have to narrate for you. He says, 1,500 years ago, everybody knew that the Earth was the center of the universe. 500 years ago, everybody knew that the Earth was flat. And 15 minutes ago, you knew that people were alone on this planet. Imagine what you'll know tomorrow. I love that because I think it just encapsulates the whole thing. Let's look at some of these examples. 1,500 years ago. In the 1st century AD, everybody knew that the Earth was the center of the universe. And this guy named Claudius Ptolemy came up with mathematical equations to actually describe the movement of the planets in the sky using cycles and epicycles. He had a geocentrist view of the solar system. Well, we call it the solar system now. He had a geocentrist view, but here's the crazy thing. Even though his equations were based upon a faulty starting presupposition about the structure and the movement of the universe, his equations worked. And they held fast for 1,500 years. For 1,500 years, everybody knew that the Earth was the center of the universe and that the sun revolved around the Earth. It wasn't until Copernicus, Galileo, and Kepler came along that was thrown out the window. But wait, there's more. In the 17th century, life from non-life was all the rage. Until a guy by the name of Francesco Redi comes along with his jars of meat. I don't know if you remember this from your science books back in 8th grade. I used to love this, love the pictures of this. So the idea was that, rotting meat produces maggots. They spontaneously generate from rotting meat. Well, Francesco Redi comes along in 1668, and he conducts this experiment where he shows pretty conclusively that no, what happens is the flies lay eggs, and the eggs hatch into maggots. But everybody knew that life came from non-life. But here's the interesting thing. Even Redi himself, Francesco Redi himself, believed that spontaneous generation could occur under certain special circumstances. It wasn't until another 191 years later when Louis Pasteur came along and he took this embarrassment of science and jettisoned it into the ash bin of history. But as the saying goes, those who do not learn from the past. Alexander Ivanovich Oparin in 1924 proposed abiogenesis, or life from non-life, in his publication, The Origin of Life. Those who do not remember the past, right? Finally, in the 19th century, everybody knew that the body consisted of 4 humors. You had 4 humors running around in your body. You have black bile, yellow bile, blood, and phlegm. And if you were sick, it was because you had an imbalance in one or more of these 4 humors. So what did they do to cure you? Bloodletting. Yeah, let's let some of the blood out. So unfortunately for our first president, his doctors knew. They were confident that the body contained 4 humors, and the way you restore health is to bleed somebody out. They hadn't read Leviticus 17:11, which says, "For the life of the flesh is in the blood." So it kind of stands to reason that if the life is in the blood and you let out all the blood, there goes the life too. People are gonna die. Our poor president was the victim of his learned physicians. All right, so I don't want to be up here just kind of ranting and raving and poo-pooing science, because that's not what I'm here to do. What I wanted to show you is that, just demonstrate that science is not certain. It never is. It's the best we've got. There's nothing wrong with it, but it's just the best we have. It's a tool. It's not the end-all, be-all of human knowledge. So, on a positive note, what are some solutions that young earthers have proposed for the distant starlight problem? It's not enough to go around saying, no, you have a problem too, right? That's not satisfying. So there are 4 solutions that John Hartnett, an astronomer, a cosmologist who lives in Australia, has listed 4 basic categories of distant starlight solutions that have been proposed over time. They are C decay, and we'll go over this one by one, so don't worry about the nomenclature too much. C decay, light created on its way, or the appearance of age, relativistic effects, relying upon special and or general relativity, and alternate timing conventions. And we'll take these one by one and take a look at each one. All right, solution number 1, C decay. C is the abbreviation, or the constant that represents the speed of light. The theory here is that light is slowing down over time and was orders of magnitude faster 6,000 years ago than it is today. This theory came out in 1987 when Trevor Norman and Barry Setterfield released a paper in that year, and it made quite a big splash. And suddenly, all the young Earth creationists kind of jumped on it, like, aha, we have a solution for the distant starlight problem. You old Earthers can go pound sand. Well, the problem is, it's got problems. The problem is that there's really no really super solid evidence that the speed of light has changed in any meaningful way over time. So Setterfield and Norman were pretty much roundly mocked when this came out by the establishment, the scientific establishment, and the theory eventually fell out of favor. However, interestingly enough, Paul Davies from Arizona State University in 2002 says, quote, light has been slowing down since the beginning of the universe. And in a paper written by Zhao Magiju and Nyashi S40 in 2016, seems to be kind of revitalizing the C decay theory. So I guess it's kind of like the fat ties, right, from the 60s. They go out of style. They go back to skinny ties in the 50s, and then in the 70s, the fat ties come back, right? So it's kind of like a fashion show. Old ideas become new again. The second solution is light created on its way, also known as the appearance of age argument. Now, when I talk to most people who self-identify as young Earth creationists, this is where they tend to hang their hats. Well, I believe that God created everything with the appearance of age. When God created the starry hosts, he made the light instantly visible on Earth, thus giving the appearance of age, which kind of stands to reason because God created a fully grown man, fully grown woman. He didn't just, fertilize a zygote and leave it in the dirt and say, okay, go for it, see you in 9 months. He didn't do that. Created fully mature man, fully mature woman. I presume they were fully mature trees. Otherwise, they wouldn't be able to eat for a while, right? Fully mature animals, the whole 9 yards. So it has the appearance of age, and it seems reasonable. But this also has problems. First, there's no clear biblical support or reason for God to do this. There's a good reason for God to create a fully mature tree, because otherwise, like I said, Adam and Eve wouldn't have anything to eat otherwise, right? They couldn't just go down to the 7-Eleven and pig out on bags of chips. It's untestable because it makes no scientific predictions. Three, it invokes the God of the gaps. The God of the gaps argument basically says that, oh, well, I don't know how it happened. God must have done it. Therefore, nanny, nanny, boo, boo, you can't touch me. It's that kind of an argument. You just kind of fall back on God and just say, well, God must have did it, and I don't have to think about it anymore, which I guess for some people is fine, but it's viewed by some as being a bit intellectually lazy. I think God calls us to exercise dominion over creation and to love him with all of our heart, soul, mind, and strength, not just give up and roll over and say, oh, God must have done it. He wants us to figure things out. And four, this I think is the most powerful argument against it, most observable events would never actually have happened. Most observable events in outer space. And here's what I mean by that. In 1987, a supermassive star exploded. And if you were fortunate enough to be looking into the nighttime sky on February 23rd, 1987, and you were in the southern hemisphere, you would have seen this. It was the first such explosion in the sky that year. It's called Supernova 1987A. The A designates it as being the first. And so this star that exploded is 168,000 light years away. Okay, now remember, the young Earth creationist position is that the Earth and the entire cosmos is roughly 6,000 years old, certainly less than 10,000. And so if anything is beyond that distance away, we wouldn't have had enough time to get the light to us. So really, if we look out in the nighttime sky, we should only be able to see stars that are 6,000 light years away. And every year we would see more and more stars. So let's dig into this a little bit and see why this doesn't work. Well, God just created this, with this explosion with the light in the way. Well, let's see how this would actually work. So we have the Earth here, and here we are on day 4,000 BC-ish, right? And let's not get hung up on the date. This is creation week, 1 a.m., Anno Mundi. And
God can do anything he wants, whenever he wants. Not everything has to be explained from his bullshit, anyway, explanation, but we'll see.
The year of the world. So this is creation week on day 4. Light is it's keeping you from seeing it, but we have the Earth here, and there are no stars. It's completely black. It's a black void. But then in Genesis 1, 14 through 19, God says, hey, let's put on a light show. So he sprinkles the nighttime sky with all kinds of lights. We got stars and galaxies and everything else out there. And let's focus on this one particular star that blew up in 1987. So we'll put that star right about there, and note that it's 168,000 light years away from the Earth. Okay, this is the star that we're interested in. So the problem is, here we are on day 4 of creation, and this is our representative stars, just like all the other stars out there. But because it's so far away, when God said, let there be, and there was, well, if light travels at the speed of light, then you wouldn't be able to see this for another 168,000 years. But alas, you could see it. So here's what God would have to do, according to this theory. God would create the light beam in transit so that if you were able to travel this distance from the Earth all the way back to the star, as you're looking out, this is what you would see at periodic intervals. You would see the image of that star. Light created on its way. Okay, that seems to work. No big deal there. So let's make the star explode. So now we've got a bit of a dilemma.
Light created on its way. No one knows what the one-way speed of light is. That's the truth. I mean, you've got the speed of light in 2 ways. They measure it by shining it at a mirror, and then it comes back from the mirror. But for all we know, the speed of light in one direction is infinite, in the other direction it's slowed down. But also, it doesn't really matter, because I've got no problems with the God of the gaps, with being able to say that God can do whatever he wants at any time that he wants during the creation. So people that try to explain these things through natural occurrences or through science, I just say that it's just bullshit. It's most of it.
Yeah, I mean, they're either choosing the God of the gaps or the Big Bang of the gaps, in my opinion. They're reaching in either way. Either side, there's, No,
I'm saying that people that about this light travel thing, like you've got the one-way light convention. I mean, how are you going to measure the one-way speed of light? And how are you going to measure the speed of light in deep space where there's no gravity? Because every million light years, there's concentric circles of no gravity, no particles, nothing to distort the light. So first of all, we don't know the one-way speed of light, and we don't know how light reacts or travels through places with zero gravity and particles and interference. And we just don't know how God himself,
Yeah, we don't know how he did it, but that's why we have these different ideas for the distant starlight problem, So, I mean, as far as my position, it's not really a problem, the speed of light, because I don't have to believe in this super fast speed of light in the very beginning, because I believe that the light was created already reaching the earth, So like the light was created with given age, just like the rest of the universe. And all of the universe was visible that week of creation. So it seems
the problem,
like this
the
guy.
problem with that is he's describing now an event that happened 168,000 light years from Earth, which means it happened 168,000 years ago, but yet we can see it on Earth, and that's what he's saying. Okay,
Yeah.
So
that's the assumption, is that they assume that it happened 128,000 years ago, because that's the assumed distance.
It's not just that. Even if the distances were right, we still don't know, and we really don't know how light travels through one way through no gravity,
through the cosmos, even really.
And we can only see the way it travels in our solar system.
I mean, they have their physical constant speed of light that they represent with the letter lowercase c, and that's the constant speed of light. But like you're saying, they don't know how it travels through the vast cosmos. Especially when you have now considering these anomalies like black holes that supposedly slow light down and trap it. Even it's like, yeah. So, like you're saying, it's all conjecture.
Well, with slowing light down, that's understandable. If you put it through a medium that's got more like milk, cloudy water with milk in it, it's gonna take the light longer to get past all the particles. Each time it hits a particle to create a shadow on the other side, but then it has to travel to the next particle and the next particle to get through all the particles. So it could literally slow light down without actually interfering with the speed of light itself. If there's a lot of particles, but also you got to remember the only way they've got to gauge the speed of light is by doing it two ways. They can never gauge the speed of light one way. So when you shoot something in one direction and it comes back at you slower, and we don't know the way that light reacts in zero gravity. We don't know a lot of things. So I have no problems invoking God and creation, because they invoke a big bang and a singularity that come into existence that had zero energy, and that equals this entire universe, because it's both positive and negative, equals zero energy, and that's why it's still inflating, and we're living in that cosmic bubble, I suppose.
Yeah, I
And
mean, the Big Bang cosmology, like the Big Bang cosmology proponents, these people that believe in the Big Bang, they have no right to criticize the creationists for the God of the gaps logic, because they have their Big Bang of the gaps that they fall back on all the time. Where did energy come from? Where did matter come from? Well, it's the Big Bang did it.
Yeah.
Okay.
How?
And a lot of them don't see it's the same leap in logic that we're making to explain the universe. So,
yeah. Oh, yeah.
But yeah, do you want to play this on, or do you want to find something else to watch? I'm sure we could find something interesting around here.
Just watch the other one. This one. Hang on.
All right. Yeah, good to see you guys all in the chat. Bubblegum Gun, Phoenix, and Big Mama and Robin, and Missing Mod. Good to see you guys. We're gonna load up this debate. I think it's the one between Aiden and Hovind again.
on this. I
Oh yeah, we got
trust
some
science.
dead air
I
here.
want
Here we go.
science of some of the
But yeah, I
dumb
was just
stuff
talking
that's
about
been
this,
included in
introduce
science.
the debate real quick to the people in the chat in case they don't know. This is a little known debate that happened the other day on Proverbs Ministries guy's channel, and it was one very near and dear to my heart. My friend Aiden was on there debating Hovind, and I was grinning the entire time. I don't know about you guys, but that was a fun one. So I just wanted to talk a little bit about what was said during the debate again. And I did say this in the beginning, but just to summarize, Ken, he understands what science is. The man, he can define it. Okay. You ask him what science is, he'll tell you. He knows where his theories begin and the science ends. He'll even tell you that this is my Ken Hovind theory, where Aiden seems to think that the beliefs and the theories, the opinions, even the experimentation that surrounds the cosmology or the science is the science itself, but it's not. These are just beliefs and opinions. Sometimes they'll say that science is done, that the scientific method is science itself, and that is not science either. Instead, that's the method that is used to gain the knowledge, which we consider the body of knowledge, which is science. So if you want to be technical, I mean, we should be, which is what moderated debates require. But moderated debates also require an amount of time to prepare. And I know that this was a very fast debate, but if they agreed upon the allotted amount of time to get prepared for this debate, then it's all fair. But I'd say that an actual moderated debate, you've got to have like a good couple weeks to prepare, get your stuff together. Kent's got slides for cosmic evolution, but I don't think Aiden really had too much to show. So
getting his ass kicked anyway. I mean, everything that Ken's saying is true. It's just I know there are explanations for it, but their explanations are complete bullshit. But anyway, let's just see.
Including evolution, which is not part of science.
Oh, sorry. I was going to just address what Robin said in the chat. She said that Ken's views are not theories.
Neither is evolution. It's a hypothesis.
Sure. Yeah. I mean, if you want to be technical, but when I say theory here, I mean generally like just beliefs, opinions formed through observation. Yeah. Not to get all semantical about it. But when you think about it, everything comes down to semantics, right? So.
All right, let's listen. Let's see.
All right.
But at first, what was before the Big Bang? This guy was asked the question. It's a mind-boggling question that has intrigued scientific theologians and curious alike for centuries. What was before the Big Bang? Roughly 13.7 billion years ago, the entire universe existed as a singularity, a point smaller than a subatomic particle, according to the Big Bang theory. Well, where did time come from? How long? Where was this singularity 75 billion years ago? You're saying at 13.7 billion years ago it started. Okay, what was 13.8 billion years ago? What was 13.9? What was 14 billion years ago? Did this singularity just exist for eternity? How far back in time do we go? Do you have a beginning for time? See, the evolutionists and the cosmologists that he wants to include his Big Bang religion, they cannot explain the origin of time, space, or matter. And he's saying, just because I've asked the same questions over and over, and I repeat the same stuff, because you guys don't have a logical answer. The textbooks they want to teach the kids, Big Bang Theory, here we go, boys and girls. The cosmos goes through super fast inflation, expanding from the size of an atom to that of a grapefruit in a tiny fraction of a second. This isn't science. This is somebody's religion. They believe this. And there might have been some people who love the Lord involved in coming up with this theory. I'm sorry, they're wrong. I'll debate them too. My point is, you need to understand, I think, Aiden, you don't know what science is, okay? How does science differ from other fields? Science is the knowledge gained using observation, experimentations to describe the world around us. Can you show me the observation of matter coming into existence from nothing? Can you show me the scientific observation where time and space can come into existence from nothing? You believe time, space, matter all came from a dot, a singularity, but you do not know where the singularity comes from. This is certainly not a repeatable experiment. It's not science, that's all. Even if it turns out later to be true. Until then, it's not science. And no, it should not be included. I'm very familiar with the theories of gravity and acceleration due to gravity and Galileo and his experiments about the big rock and small rock falling same speed. I taught physics for years. Okay, I'm familiar with that. That's got nothing to do with what you're talking about. This was a rabbit trail you tried to throw to people. Got nothing to do with it. I like physics. I like chemistry. I like biology. I like earth science. We're standing on a planet that's pretty big, almost 8,000 miles in diameter, a little wider at the equator. And it is, you think all that fit in a dot. It is incredulous. And for you, I keep saying these things because you guys do not ever give a logical answer. You just say, well, we have to believe it. A lot of other people believe it. That's the only alternative. It's not the only alternative. God made everything. And you want to say, where'd God come from? I don't know. But see, I admit mine's a religion. You do not admit yours is a religion. You have nothing but a religious belief. I happen to think it's dumb to believe that, but you're welcome to your religion. But you're not welcome to force everybody in the country to pay for your religion to be taught in schools. That's all. Okay? So there is no observation. It's not testable. It's not repeatable. What is science? It comes from the Latin word knowledge. Okay? Seer, to know. What do we know? Well, it's a systematic enterprise that builds up and organizes knowledge in the form of testable explanations and predictions. I predict that we cannot compress matter. We cannot compress a cup of water down to the size of an atom. They're saying now, which I forget the number, was 1,000 atmospheres or 3,000 atmospheres of pressure to squeeze it 7%. Then you got to ask the question, how many atmospheres would it take to squeeze it down to an atom? We don't know. It can't be done. So far as we know, it can't be done. And if it could be done, who's supplying all this energy? Who is squeezing it that hard? And you want, that's just a cup of water. You want the whole world squeezed into this dot. All I'm asking is for you guys to admit your religion is Big Bang. Cosmology, the study of the stars, no question. We can talk. I love that stuff. You want to talk about which galaxies are out?
They believe atoms and subatomic particles just came into existence and formed into complex structures. And like there's literally no evidence at all that there's
let's go to the Harvard article. If you look up cosmic evolution on Google, can we show this Harvard article and show how they believe particles first formed, and then those became gases, and then basically gravity condensed the gases into stars magically, and then magically stars were born. Like they think they're still born that way now, and nebulas in the universe. So it'd be really interesting to know exactly how they think these stars form. And they're always lost in that because they're just like, well, they just do. Because there's your Big Bang of the gaps logic again. Because, there they are. So we have to rationalize them with they just happen that way. The Big Bang just works that way. And big old granddaddy stars blew up and became even smaller stars. And here we are. So. And here we are with the sea stars. Anyway.
Hey, it's telling me there's no searchable results for cosmic evolution theory in Bing.
Oh, no.
Not in Bing, but we know Bing is
cosmic
rubbish.
Evolution, and then Harvard, and it'll bring you right to the article. Guaranteed.
I mean, it should come up with straight away. It should have come up with.
And there's actually a photo. So if you do that and then you click the photo tab, you'll see it right away. And it's like a chart showing basically cosmic evolution, which is particle to star and planets. Solar system.
I'm gonna really insult Edge browser here and go into a Google search on this.
All right. So yeah, I just wanted to reinstate that before this part of the debate here we're watching. Hovind said again and again, cosmology is the study of the cosmos. It's not the opinions and theories that are formed around it.
Site summary. Harvard. There we go. Okay. When consciousness, oh man, that is just too much.
And I'd say I agree with them on that. I mean, Hovine's right on the money. You know, cosmology is the study of the cosmos. It's not the beliefs we form around the cosmos. So, but you know, the atheists, they want to cram everything into that facet of science and not differentiate between the theories and the science itself, which I think is important because, and that's what Hovine's really saying, is he wants to keep the science in the schools, get rid of the theories. You know, and I mean, like, not even that. I think he wants to teach everything, but I'm not sure his opinion, so I'm not going to speak for him. My opinion is that we should teach the kids everything. I think we should teach them cosmic evolution. I think we should teach them creation. I think there should be a class for origins, like an origins class of science, and teach it as science theory, you know, so, but that's just my opinion. I think they should teach them everything. All knowledge should be learnable, especially at the higher levels of education in college and so on. So,
yeah,
but I'm full of opinions. But do we have that? Do we have that? The chart yet, or something just kind of showing this particle evolution? Because it's just like, it's like connect the dots, man. Can't you tell? It goes from particles to gas to stars, and that's just how it is. We already know. Even though we've never seen a star be born, you know, we've seen them in the nebulas appear, but knowing that nebulas are gaseous bodies out in the cosmos, and that a star could kind of come out from behind a cloud, you know, it'd be like the same thing as seeing the night sky and a cloud and comes in front of a star, and then seeing it come out the other side and imagining that star was born. That star must have been born. But the thing is we've never seen stars be born. We've seen lights in the vast cosmos, these explosions, you know, and they imagine that might be the beginnings of stars, but you know, they don't actually have the life of a star, because they'll tell you stars take millions of years to form. So unless you have Doc's time machine, you can't go and see it.
Yeah.
And that's their Big Bang of the Gaps theory. So cosmic evolution. Yeah, there you go. We have a peer-reviewed article using the term. It's a real term. It's just a term that refers to a model, not science. So, and it's a cosmological model, but it's not part of cosmology. So, the Big Bang is not cosmology, because cosmology is the study of the cosmos. So the Big Bang is definitely not cosmology. That's something that's purely assumed from what we've observed, but it's an assumption all the same and not science. It's not observed truth. It's not systematically gained knowledge. It's systematically gained assumptions and conjecture, guesswork at best. But yeah, so just a biological evolution is the heart of modern biology. Cosmic evolution is the heart of modern cosmology. For instructors to be confident in teaching science, it is helpful for them to appreciate the current understanding of the composition and development of the universe, especially the revolutionary changes that have taken place in our understanding over the last 2 decades. Biological evolution requires the products of cosmic evolution. The elements of which life is composed were formed in the cores of stars. Wow, amazing, they know that. And the 2 areas of science are thus crucially and even inspiringly connected. Isn't that amazing, guys? Don't you all feel inspired? We're all stardust. We're all connected. We all came from the sun, man. Anyway, that's humanism for you. Or, well, what is it? Humanist? Anyway. Lucy just looks like a the bonobo to me. Yeah, well, the jaw definitely does. What they have of the jaw in the first family collection. So, we could talk about some hominids too here eventually. I kind of wanted to show like a photo, and I'll get it some point. I'm gonna go get it actually. If you want to give your opinion on cosmic evolution, if anyone wants to hop in here with us, if you feel motivated, I mean, we'll talk about, you know, cosmic evolution in this debate. We'll watch the debate together. So I'll be right back with that photo.
Cosmic evolution. Well,
all right, I've got the link at least, so I'll just throw that into the private chat. Did I lose my avatar at all going on that adventure? All right. Yeah, the link's in the private chat to that photo I was talking about. And this basically, it just shows, you know, their model of the origin of the universe and the contents of this universe. So it's important to understand the Big Bang cosmological model. And again, like I said, I don't have a distant starlight problem. At least I've solved it in my mind, because I go with what I think the Bible, or how I interpret the Bible, which is that the light itself, the starlight itself, was created already reaching the earth. And I think that in the first chapter of Genesis, it explains that, you know, the light was visible. The light of the stars was visible during the first week of creation. So this whole idea of light starting off super, super infinitely fast and then slowing down, or we're all closer together in the beginning, kind of goes towards the Big Bang idea more. You know, if they think that we were that close together where the light would already be reaching itself because it's infinitely fast and we're so close together, that sounds like we're expanding a lot more. We're like, in our model, or in my model, it would be that we would only be expanded as far as 6,000 years from the initial creation, with where everything's spread out already. So I think that makes a lot more sense than assuming the speed of light has changed infinitely over the course of time, or the course of the universe. So, I think the entire universe and its contents were created with a given age, from Adam to the trees he ate off of that week, to the stars in the sky. Okay. The planets were all created with a given age. So even if, you know, there are geological layers on Mars, even if they weren't created by the wind, even if they were created by water, like this could have all happened in the last 6,000 years. But where did all that water go? That's a good question. If there was all this water on Mars, and they're trying to claim a global flood on Mars, like that's a lot of water to account for. It doesn't just go out into space. Maybe if it got hit with a big solar flare, I don't know. But like there's a lot that could have happened in the last 6,000 years. So a lot of what you see in the universe that's broken down, a lot of the disorder that's out there, you have these asteroids flying around, ramming into things. Like all this could have happened in the last 6,000 years, depending on what's happened up there. So, what are your opinions there, Jason?
Well, I reckon the Earth would
About that?
smashed to pieces by asteroids many times over.
Oh yeah, if it was millions of years of cosmos, yeah, the asteroids would have demolished the universe by now. Or, you know, the universe would have already been broken down at the rate that we're seeing it fall apart. And I say the same thing with like the environments on this Earth right now. Like we're seeing all these animals go extinct
People
in our
don't realize.
lifetime. And we're supposed to believe that these animal forms have existed for hundreds of millions of years on this planet, going through ice ages and climate changes over and over, and we're losing them now. That makes no sense. So evolution makes no sense.
People don't realize the planetesimals that they see out there are traveling at like tens of thousands to hundreds of thousands of miles an hour. They don't just float around in space and just gently touch together and form into bigger and bigger objects. They get to a certain size and they're traveling at such a high speed that when they do come into contact with each other, they smash into dust again. That's one of your big problems.
Sure.
All the trans-Neptunian objects are traveling at tens of thousands of miles an hour. If they touched each other, boom, dust.
Oh, yeah. The force of atomic bombs going off, more than that. And supposedly you don't hear any of it out in space, right? Yeah.
Yeah.
But I can't wait till we all get up there and flying around.
Well, they all seem to think that these objects just come together and just slowly like merge, like in the movies where you see the asteroid belt and they're gently floating around these asteroids or planetesimals, just gently floating around and bumping into each other and then bumping off each other. No, in reality, they're traveling at tens of thousands of kilometers each in all different directions, and they're spread out over such a massive distance that the chances of them touching each other are almost zero. And if they do come into contact with each other, they're just going to smash each other to pieces. And then they have to start. They get to a point where they have to keep starting over and over and over again.
Yeah, and I mean, there is some what you could call sound in space. Like P-Town was going on about before, with this cosmic background radiation. When they discovered this in the early part of the last century, these cosmic rays, in the first place, cosmic rays were discovered first, and then cosmic radiation was discovered later, or defined later, I suppose. And that was around the time of the experimentation with the big ear-looking thing, where they used to catch the sound from what they're claiming is the cosmic microwave background, which, I mean, it is. I mean, but there's a lot of radiation coming in. It's not just microwaves. So you have all these cosmic rays coming in through the Earth, gamma rays, so on and so forth, degrading it. But it's also, that's the fuzzy stuff on your television back in the day. That same percussion is what you're viewing on the television with that static. So, and the sound even on the radio. So those are that's that interference coming. That's the cosmic radiation. We hear it all the time now. But yeah, it was discovered closer to the middle of the last century, and then it was used to claim that that's evidence for the Big Bang. And it's like, well, what you have here is a phenomenon, this anomaly, this cosmic radiation. We don't really understand the source of it. So because we don't understand the source, because that's the edge of your understanding, we're going to reach to Big Bang. And that's your Big Bang of the gaps right there, filling in the gaps of knowledge with, the Big Bang did it. It must be percussion from that. Well, it's like, well, as a creationist, and I don't believe in the Big Bang, I believe that, there's another reason for this percussion in the universe. It could be exploding stars. You know, there's a lot of things in this universe, obviously, and we don't understand it. I mean, man, we just circumnavigated the globe. Let's be real. We don't understand the universe. And to say that we understand the source of all the cosmic radiation, that this would be the Big Bang, that's a leap in logic, and that's the Big Bang of the gaps. So the Big Bang solves every cosmological problem for them, it seems. What do you say, Jason? Did you see that link in the private chat yet, man?
Let me have a look.
There's a link to the photo I was talking about, and it shows particle. I don't know if we'll be able to see it close enough because it's kind of far out on the Harvard channel. I could probably blow up the screen a little bit more, if anything. But yeah, before we go on with the debate, I just want everyone to be able to see with their eyes like a model of cosmic evolution. All right, I don't know if you guys can really see that, but oh yeah, sort of. All right, so you have particulate, galactic, stellar. I can't even read that after that, but well, maybe I can. Can I zoom in? Oh, can I zoom in on my studio? I don't know. But yeah, so there you have it. It starts out with particles, and it moves all the way up to cultural. Okay, that's going. Oh yeah, there's biological there. Okay, so we're looking between particulate to biological. Everything between there before biological is what they're assuming before biological evolution. So when the evolutionists say we don't have to account for cosmic evolution, which isn't something Aiden said, and I'm not saying that he said that. So before Aiden goes and says, and I'm putting words in his mouth and saying that he has that, I'm not straw manning him. Don't want to step into that. Don't want to step into that circle. So, but it's my opinion that they have to account for cosmic evolution if they're going to go on and defend biological evolution. And it's always a good point to make that they're assuming all of cosmic evolution from particulate to planetary, chemical, all the way to chemical. And then they're just trying to explain evolution or biological evolution. So they skip abiogenesis, and I guess that would be the chemical evolution, the forming of chemicals, and then them forming into the first amino acids and then life. You know, so that's their model. And here it is, an Harvard University site. That's really their model. And now, if you don't mind, we could probably go back to that debate and watch the remaining parts of it, I suppose. And if you want to walk your dog or whatever, you probably do that now too. We'll scoot on with it. If you're still around. Ooh, pizza, Robin. Yeah, I had pizza today again. That was delicious. Oh my goodness. Just delicious. And I cooked it just right, 350, 360 for like 27 minutes. It always comes out perfect. But I don't know if I'm by myself now. I feel so alone. Jason, are you there, Jason? I'll just talk to you guys in the chat. Hey, Robin. Hey, Missing. Oh, you're there.
Getting the dogs out. I'm just doing
brother.
some stuff. So,
Well, could you start the video real quick, and I'll just watch that while you're walking the dog or whatever.
Okay, okay, this one, yes. All right. Hang on.
Otherwise, I'm going to do about a half an hour improv, maybe. And, the people in the chat will, it could get fun. I know a couple jokes, but nothing worth, nothing impressive. I know that. I know enough to know that. But look at the beautiful sunset. Right on the beach. It's the sunset on the beach today.
There you go. So I'll start that.
Sure, man. I'm gonna just change this view again.
They're expanding and all.
Right, I got. Right.
Thanks, Jason.
Size of the different stars, Sirius, the giant star, the great big huge stars, no question, and all the different planets and all the moons going around the planets. I like that stuff. Okay, I taught her science 15 years. Love studying that. But you want to sneak in Well, boys and girls, it all fit in a dot smaller than an atom. And that's the dumb part of this whole discussion. That's not science. Galileo discovered some great things. And the fact that a bunch of people in his time frame believed something that was wrong, and Galileo proved them wrong, well, that's wonderful. That's what science is supposed to do. That's what I'm trying to do with you, Aiden. You believe something that's wrong. I'm trying to help you. You believe everything fit in a dot. It's not science. It's not logical. You can't do that. Okay? Religion's attempt to understand and explain the world. I agree. But religion is not considered science. I agree. That's why evolution is a religion and is not part of science. The Big Bang is a religion and it's not part of science. All the evidence we have is stars appear to be expanding away from Earth. Redshift. End of evidence. Now we can interpret that probably they used to be closer. That would be a reasonable conclusion. But you want to draw that back to they all came from a dot? Now that's not a logical conclusion. They could have just started expanding 5,000, 6,000 years ago. God made everything. He made the Earth first, and then he made the stars. My book tells me that. And then he stretched them out into space. So I would say my theory would be he made the Earth, then he made the stars, and stretched them out, and we're still seeing the red shift of seeing the taillights of the stars as they're racing out away from us. That theory would fit the evidence. The evidence is red shift. It is not scientific to say it all fit in a dot. It is logical to say they all are going away from the Earth, or nearly all of them that I know of. I think all the stars or galaxies give a red shift. Okay, they're all moving away from the Earth. I would agree with that. And it all started 6,000 years ago when God made everything. Let's see. And you say, Kent Hovind's not honest. It's because it's incredulous. I'm completely honest. You're the one that's not honest. You won't admit Big Bang is a religious belief. It's not from science. Science, how do you define science? Knowledge gained through study and practice. Science refers to a system of acquiring knowledge. Okay? System uses observation, experimentation to describe and explain natural phenomena. Well, the Big Bang does not fit into that category. You can't observe anything. You can't observe a dot of nothing exploding like that. You can't observe this happening with no intelligent designer. It's not science. That's all. I wish you guys would admit it. Let's see, right here. Cows make cows. These charts they put in our textbooks are not science. This is a religious belief. Nobody's ever seen a monkey produce a non-monkey, or an ape produce a non-ape, or a baboon produce a non-baboon, or a gibbon produce a non-gibbon, or a gorilla produce a non-gorilla.
Not the topic of the debate, Ken. Not the topic of the debate.
Well, my point, this is an example of how this is, you guys believe this stuff. I like this one. What if I told you questioning science is science? I think we should question. I'm not questioning cosmology. I'm questioning the cosmic evolution, which starts with a Big Bang of nothing exploding. This is what they're saying. European Space Agency said the universe grew from smaller than an atom to bigger than a galaxy. If you agree with me that that's not really scientifically provable, would you help me get that out of the textbooks then? Because this is the stuff the textbooks are teaching our kids. Why should they be taught to learn this?
Well, you totally just conflated what I said, Ken. You totally just.
Well, Aiden, he's got 2 more minutes, please.
Shut him off. I did not interrupt him one time. Okay.
Go ahead.
He covered about 20 topics. Okay. I tried to write as fast as I could. So the Big Bang religion does not explain the origin of time, space, or matter. It is not science. Science, he said, science is not dogmatic. You need new information. Okay. There's no information to say the universe was smaller than an atom. If you wish to believe that, believe whatever you want. I don't care. But that's your religion. Believe it. And if he gives me his extra 5 minutes, I still got 7.5 minutes left. Okay. You said there's a hard light barrier, and religious people did believe in the Big Bang. So what? All kinds of people believe crazy things. There's all kinds of religions out there. I think everybody in China, and now they believe, maybe they're forced to believe, that communism is good. And if they disagree, wow, you don't get a job, you don't get food stamps, they probably executed. So the fact, you can't go by majority opinion ever, okay? That's a crazy argument for anything, okay? And even if I'm in the minority, doesn't matter. The fact is, we don't observe this kind of stuff. You really think everything, all of the matter in the universe, I should put another T in there, fit in a dot. That's what your religion teaches. All the mountains, all the people, all fit in a dot. I just saying, it's not just incredulous, it's stupid. It's not science, that's for sure. I think it is incredulous. It's certainly unbelievable. I'm not going to believe it. You can choose to believe it if you want. I'm not against you. Believe whatever you want. But quit calling it science and quit trying to put it in our textbooks. That's all. I yield the rest of my time, Stephen. My throat hurts.
All right. So what we'll do now is we will go into the cross-examination. We will do 5 minutes where Kent can ask direct questions to Aiden and Aiden can answer. We'll try very hard, gentlemen, not to overspeak each other. And then Aiden, you'll have 5 minutes likewise to directly question Kent and he can give direct answers. So Aiden, if you're prepared, you can go ahead.
Yeah, no, Kent, fire your first question away. I'm ready for you.
Where did time and space and matter come from initially? Where was all this time, space, matter 13.9 billion years ago? Where was it?
13.10 would be 14 billion years, first of all. Oh, come on. Can't you make jokes sometimes during debates? Come on, don't scoff. Anyways, the point that I was going to make, though, is that it's not the purview of the Big Bang to be able to describe where those things came from. That is not the purview of the Big Bang, and it's never been something that's been postulated by the Big Bang to try and describe. It would be just as ridiculous for me to ask you, Kent, where your cosmic evolution takes the internal combustion engine into account. It's a total non sequitur that has nothing to do with the argument.
Aiden, you're doing nothing wrong, but if you could try to make your answer shorter so Doc can ask you a series of questions, it'll be more fruitful for everybody.
I'm not trying to drag them out too long. I apologize.
Okay, so I understood your answer to be, we don't know where time, space, matter came from, and we don't know where it was 13.9 billion years ago.
That wasn't my answer.
Where was it?
My answer is that it's not the purview of the Big Bang Theory to be able to describe those things, and it's a non sequitur for you to come at me and ask me how it describes those things when the theory itself does not postulate to describe those things.
Okay, you're wanting to start with something that you don't have an answer for. I do that also. I start in the beginning, God. Where'd God come from? I don't have an answer. You don't know where time, space, or matter came from. So we both are on a religious quest here.
No, it's not actually. It's simply not. It's not a religious belief, because what we say is that we don't know. You say that God knows. You do think that there is an ultimate solution. There is an ultimate answer to that question out there, but it's just under the purview of this super intelligence, this entity which holds total knowledge and understanding of the universe at large. You do think that there's an answer out there for that, and science doesn't claim to have that answer. So no, Kent, in spite of what you're trying to do, they're not on the same playing field.
Okay, you use the word "we." Are you included? Are you a scientist and you're involved in this group that believes in the Big Bang?
I meant we in terms of people who participate in these kinds of conversations, like we are currently doing right now. I am not a scientist. I would not claim to be a scientist.
Well, then I'm part of the we also, and I don't believe it. Okay, I don't believe. I think you're trying to not admit very simply. Do you believe time, space, matter came into existence 13.773 billion years ago, or whatever number they're using today?
No, it was within the singularity. Time, space, time, because space and time are not separate things. It is space, time as an expression of the fabric of the universe that we live within. That was within the singularity. So yes, it did exist. It just existed within an extremely small, condensed period of space.
So what was outside of that singularity? What was behind it, above it, beneath it, below it?
What could be outside time and space, Kent?
Well, so you're saying you don't have an answer? You don't know what was outside of your dot, your tiny atom?
Well, space and time are the mediums in which we exist within. So the easy answer to your question would be nothing, because really the long answer is nothing that we could actually comprehend or experience, because we exist within space-time. Asking what is outside of that space-time is a bit of a silly question in the face of the fact that we only live within that space-time within our universe. It is expanding into nothing, because if there was something in the way for it to expand into, that would be a material, that would be space, that would be time, or some sort of material within it, and that would be inherently contradictory.
So where did the nothing come from outside of the space-time?
Once again, as I've already explained, Kent, that is not the purview of the Big Bang Theory to describe. You are trying to ask me something that is a non sequitur in relation to what the Big Bang Theory postulates about our universe. It would once again be like me asking you what your cosmic evolution theory has to say about the internal combustion engine. It's a total non sequitur, Kent.
Oh, it's not. I can explain it very simply. Internal combustion engine. God made everything. God made everything. He made the materials. He made the earth. He gave people a brain. People with brains have learned how to extract metals from the earth, how to synthesize them. How to anneal them into different objects, how to melt them down, smelt them down, make internal combustion parts. We've learned there are certain fuels in the ground that probably came from Noah's flood, from animals, and they explode. Wow, let's make them explode in a cylinder. I can explain very clearly how an internal combustion engine works.
No,
God
but I
made the
asked you to
material.
explain how it relates to cosmic evolution because it doesn't, Kent. That's the answer.
does.
Those are
Yes,
not
it does.
within the purview of it.
It does. God made the material, and God gave man the brain to use this material to make all sorts of things. They can make an ink pen, for heaven's sake. This doesn't make itself.
That
In your
you just
in your
use a big
cosmology,
sequence of words and then say that it related to cosmology. That did not relate anything to cosmology whatsoever, Kent. You're still failing to demonstrate how it relates to cosmology.
okay, in your cosmology, all the atoms that make up this ink pen were in a dot smaller than an atom, and they just formed. You don't. You see, you're
No,
still,
they didn't spontaneously form, though. That's actually a misrepresentation
Hey,
of the theory.
Gentlemen, that 5-minute segment is over, so we'll hand it over to Aiden. And Aiden, you can now have 5 minutes to ask Dr. Hovind short questions, and hopefully we'll get short answers, and then we'll be able to have more time for back and forth. So Aiden, at this point, take it away, sir.
Sure. So, do you postulate that creation ex nihilo, meaning for the Latin creation from nothing, is true in a biblical sense, Kent?
oh, absolutely, it has to be. There has to be a beginning of time, space, matter. I think God did it. God exists outside of time, space, matter. I believe a God created this. You believe it created itself. You have a religion worse than mine. I admit God did it.
All right. So, thank you for answering. The next one I would say is, would you have to see a mountain form over the course of your lifetime in order to know that that mountain was formed?
Would it
Over a
have to
very
be-
long period of time?
Would it have to be a mountain to know it was
No.
formed over a long period of time? I
No.
don't think.
Would you have to see a mountain form over the course of your lifetime
Oh, okay.
to know that that mountain formed, even if you were not there to see it?
I missed the word see. Would I have to see the mountain form? No. I believe mountains are there. I've climbed several of them. I believe mountains exist because God created all the matter, and Noah's flood rearranged the crust of the earth. And I can see a mountain either going up, or if it's rising up because of isostatic rebound or mountain building, or I can see it eroding down, and I can say, wow. I can observe it eroding flatter or coming up from isostatic rebound and say, wow, there's a mountain there. Yep, I've climbed several of them. Can I extrapolate that billions of years? No, that would not be science.
Okay, thanks for answering. My next question would be and this is the beginning of it. The Big Bang Theory has evidence supporting it in forms such as the cosmic microwave background. How would your creation worldview take the cosmic microwave background into account, and what would your explanation be for the cosmic microwave background from a creationist perspective?
Well, if we're seeing background radiation coming from the universe and we're detecting it on Earth, I'd say that's pretty cool that man is smart enough to make a machine to detect it to begin with. That must prove some kind of level of intelligence for the humans that God made. And there may be several explanations for what's causing that. Okay, one is the red shift, the stars moving away from us, and the stars are.
The difference in temperature between the warmest points and the coldest points in the cosmic radiation background, well, is 100 millionths of a degree. So you've got the warm point, which might be, only hundreds of millionths of a degree warmer than the coldest point. So there's the variation you have. Not very much at all.
Are putting off more than just light. They're putting off different kinds of radiation. I agree with that. And we have machines to detect that. We can detect the ultraviolet, the infrared, things beyond the color spectrum. That doesn't prove anything have to do with the Big Bang. That's a non sequitur, as you call it, not part of this argument. So yeah, we can detect those things, and I think they're worth studying. I love it, but it doesn't prove the Big Bang at all, or even give it evidence for the Big Bang.
I'm simply asking you the questions that I've had prepared. If you think it's a non sequitur, I'm sorry that you feel that way, but I feel like it's very much so related to the Big Bang as a theory. I would like, because I don't necessarily have any questions, I was actually quite interested in something that Kent said in relation to the redshift, because Kent made a claim earlier in the debate that he agrees that we observe redshift. He agrees that we can see it happening, but what he says is that the redshift is a result of God stretching out the heavens. It stretches it out. They may have been really close to each other at one point in time, but he just stretched them out, and it may appear like it's 13.8 billion years old rather than 6,000 years old. If that was the case, then redshift would become so extreme at that point, because the object is accelerating faster than the speed of light, that we would not be able to see anything past 6.
Yeah, I'm still here with you, brother.
6,000 years. We would not be able to see anything whatsoever past a 6,000 year hard light barrier around us that we actually observe closer to 13.8 billion years away from us. That's where we observe this sort of cosmic hard light barrier. We don't see it 6,000 years away. And that correlates to a old universe that is not 6,000 years old, because the reason why we have a hard light barrier is because at those distances that were described, it's accelerating away from us so fast that, much like in the Doppler effect, when something is going away from you long enough, you'll no longer be able to hear it. You will no longer be able to see that light in terms of its wavelength. It's simply been stretched out too long for anybody to actually be able to see it. So no, I don't agree with Kent's assertion that it could just be stretched out, because even if that was the case, we would only be able to see a tiny amount of the universe that we would be able to see right now.
I think that answer that question, if it's a question, makes no sense whatsoever.
No. It wasn't a question. I actually admitted that I didn't have any more questions at the outset of that. I just wanted to focus on something that you had said earlier that I found interesting.
All right. Well, if the stars are accelerating away, if they're gaining velocity, the stars are going faster. I think everybody that knows physics would say it requires an energy input to accelerate a mass like that.
Well, the mass isn't actually moving.
The mass is not moving. The stars are not moving?
No, the space between those stars is expanding, but the stars themselves are not moving away from us in that sense.
Does anybody...
How are we looking, Jason? Do you have something to add to this?
The space in between the stars is expanding and moving apart, but the stars themselves are not moving apart. Kent, you're wrong. You're wrong. See, Kent, you're unscientific. What a buffoon.
Well, I'm not going to add to that.
Here, let me give you.
All
Let me give you an example.
All right, gentlemen, we're at our 5-minute mark for the questioning back and forth. So we'll let you.
Are you going to add to that?
Oh, he got rescued. He got rescued. But let's see if Kent pushes on with it. Be interesting.
To go continue your back and forth. You can each ask each other a question, and the other can answer, and then switch off. Please be mindful not to overspeak each other, and let one another ask the entire question before you begin answering. And Dr. Hoven, you can go first.
So the stars are not moving, but the space between them is expanding. I like that. Next time I get pulled over for speeding, I'm saying, officer, I was not moving. The space between me and my house was expanding. I wasn't speeding. You realize how silly that sounds? That's what you're saying. The stars are not moving. The space between them is expanding. Come on.
Ken, if I have two dots on a balloon and I blow that balloon up after I've made those two dots on that balloon, and I have a grid that makes sure that that balloon and the distances between that balloon are maintained, are the dots moving on that balloon? No, they're not. They're fixed points, but they are moving away from each other in spite of that. The fact
This guy's been blowing his brains up with something really, really like strong. As a matter of fact, mate, I'd like to ask him what it is. It's like I might be interested in trying some. I mean, this evolutionist guy, he's just they're just clutching at straws.
that they're moving away from each other in spite of the fact that they are stationary objects in this example goes to show that yes, the space between things can increase without two fixed points actually moving whatsoever.
Okay, let me try to explain it to you.
The space can inflate in between planets and objects, and like stars and planets, and they're moving away, which he admitted is hang on, shush up, dog. Is redshift. Sorry, my dog. Is redshift, which means something's moving away from you, but they're not actually moving away. It's just the space in between them expanding, which doesn't actually increase the distance between 2 points, he said. But he just, anyway, it's embarrassing.
Well, yeah, I mean, as far as
say
my
this, the little moon
understanding,
globe
I'm
is a,
sorry, let me, I didn't mean
hold
to
on.
talk in front of you. I meant to warn you first, but yeah, I mean, as far as my understanding, it's like the contents of the universe are all moving apart together, you know, that's about it. So,
Yeah, it's pretty stupid that what he said is that he believes in redshift, which shows that things are moving away from us, because if something's moving away, it creates a red spectrum of light. If it's moving towards you, it creates a blue spectrum of light.
Sure.
They're moving away from us. But then he said, so that means that there's points moving away from other points, right? But then he said just then, contradicted himself and said, but if space inflates between the stars and so on and so forth, that
right, they're either on the outside of that balloon or it's all consistent.
But it doesn't increase the distance between 2 points. What is it? Is redshift right, where things are moving away, or is the space inflating between things that doesn't actually increase the distance between 2 points? I mean, if space inflates in between an object, you would imagine that the object was being moved apart, so it increased the distance between 2 points. But apparently, in the evolutionist religion, like faith, it doesn't, because it takes pure faith to believe this, and these gentlemen's are right.
That's right.
I put 2 dots 1 inch apart. I blow it up. They're now 4 inches apart. Yes.
Can you pause
the
it again,
dots
though? I don't want to interrupt
move.
Ken again. We should scroll back a little bit.
No,
but
they
let
didn't.
me interrupt you one more time. I also wanted to add, and I was trying to say earlier in this little discussion I had with Aiden on Missing Mod's painting show earlier on Charles's channel. I was trying to explain to Aiden, you know, they have all these different epochs in the Big Bang cosmological model. You know, you have the Planck epoch, you have the inflationary epoch. You know, he says that in the Big Bang theory, there's no before the Big Bang, when this just isn't the case, because the men that hypothesize the cosmological model, the Big Bang model, even the gravitational singularity that we know now in the modern Big Bang model, the men that hypothesize that, I totally lost my train of thought. Man, I was really going somewhere too.
Sorry.
How'd that happen? Where does it go? I don't know. Yeah. Were you following me at all? I don't know. Play on, sir. Play on.
Just tired. I gotta hit the sack. I'll play this. And
Oh,
just
are you
go to bed.
done? All right.
No, I'm tired, but we can play this if you want.
Okay,
but-
yeah, no, yeah, let's finish this out or whatever. We might as well. We started it, so.
Okay. All right.
All right. Oh, yeah. No, let me finish up. I just had one more thing to say before you hit the sack. Yeah. So they believe in these different epochs, in the Big Bang cosmological model. They have the Planck epoch, which is pre-Big Bang. So they actually do have a story for before the Big Bang. And a lot of the YouTube atheists, they'll claim that, there's no part of the Big Bang theory has to do with pre or before that gravitational singularity, when in fact the men that hypothesized it, including the Big Bang theory, that there was no phenomenon. It was part of the Big Bang theory that there is nothing before the Big Bang. So they're wrong, because Stephen Hawking actually wrote that there was nothing before the Big Bang in this model. So they're quite wrong. We're quite right. And, all they can do is talk over us. So to keep that from coming out, I suppose. But yeah, exactly. But yeah, so you have the Planck epoch, but then you have the inflationary epoch. So let me talk about that real quick too. And Jason knows, definitely Jason knows. It's the very first fraction of the second of what is supposed to be the very first part of the expansion. So right after the Big Bang, the very first second of that Big Bang in their model, the entire universe and all of its constants are traveling many times faster than the current speed of light. And in fact, the current rate of expansion, 5 times faster, I think, than the current rate of expansion. Now, the problem I was trying to explain earlier is that in this model, in this inflationary epoch, they have these contents of the universe speeding out infinitely faster than the speed of light. And then even now, you have this idea where these contents are moving, which is like, can matter even move faster than the speed of light? Isn't that against physics itself? So that's anti-science right there. You have all these contents moving faster than the speed of light. I'm pretty sure, matter can't even move faster than the speed of light. But here's the thing. Now the constant the Hubble rate is what is called the Hubble rate of expansion, which is the current rate of expansion of this universe, which we all believe in, creationists and evolutionists alike. It's been proven that this expansion rate is increasing, okay, at an exponential rate. So it's getting faster and faster. It's expanding faster and faster now. The problem is they believe in the distant past, at the beginnings of the universe, it was moving faster than it is now. That's a logical problem that they have to deal with. And that's I don't have a name for it. So we have the distant starlight problem as creationists we have to deal with. But they have their inflationary speed problem, I guess it would be. Because they have the constant, this is a constant of reality, though, a constant of the physical universe, that the universe expands at this rate, this Hubble constant, okay? But here you have in the Big Bang theory, something that goes against that physical constant, something that's much faster than the physical constant is now. It makes no sense. So yeah, but play on from there. I think I got my summarized opinion in.
Okay.
Unless you have something to add, brother.
Because
Probably
they're
not.
stationary. The dots don't have any. Well, Kent, please explain to me the mechanical motion that the dots imparted to be able to move to a different location. Because they didn't move anywhere. They're a fixed object. The only thing that is moving, so to speak, is the expansion of the surface of that balloon. That is the only thing that is moving, is the internals of that balloon. It's not the dots that are moving. It's the space between those dots that is moving.
So if the dots started off an inch apart, we blew it up and they're now 3 inches apart, they
Right.
didn't move. Is that your contention? The dots didn't move.
That's correct. The actual physical dots themselves did not move. It was the space between the dots that allowed for the space between those two dots to expand.
So is the Big Bang like a balloon? It's a solid surface. The balloon has a surface, and the surface is stretching. So what's outside of the balloon and inside of the balloon? What's
Well,
inside and outside of your Big Bang balloon?
Well, we're talking about the expansion of the universe, which is something that, I mean, the Big Bang and the expansion of the universe are not necessarily the exact same thing. So I feel like you're just kind of trying to correlate those two things together. But when you're talking about what's on the outside of the surface of the balloon, it's obviously everything that is not within the balloon. And everything that is within that balloon in your example is our universe. And what is contained within that universe? Space-time. All of space-time, as a matter of fact. So yes, there is things within that balloon, but there cannot be things without that balloon, because if there were, then there would be space-time. That means that there would be other balloons, and that gets into multiverse theory, which I don't think either one of us have at the time to be able to get into right now.
Okay, so if we have a balloon that's 5 inches in diameter, 2.5 inches from the center to the surface, the dots are 1 inch apart, we blow up the balloon, did they move away from the center? You're saying they did not move away from each other. Did they move away from the center of the balloon? They're now 10 inches out there.
Right, and this is where the example of the balloon unfortunately breaks down, because when we're talking about the universe as a whole, everything is expanding away from everything else. It's not expanding away from a centralized point. The only way that could be true is if we just so happen to be situated right at the center of the universe. But the only problem with that, as a theory, is that we would have to be incredibly lucky just to happen to be right at the center of the universe, unless there was a creator. But I mean, hey, we could get into that another time. But the main point of contention against that is the fact that no matter where you would go in the universe, if I teleported you somehow right now, Kent, to Andromeda, right, like instantaneously, if I was able to violate the laws of physics, boom, you're in Andromeda right now. That hard light barrier that we see of the universe would be 250 million light years further into that than what we observe right now, because it's all relativistic to one another. That is why general relativity and special relativity are concepts that are extremely difficult for our minds to grasp. Just because, however, they are difficult for our minds to grasp, that does not mean that they are not true, and that does not mean that they have not been demonstrated.
Okay, it also does not mean that they are true, okay? And you say you violate the laws of physics. No, that's what their Big Bang theory does. Violates all the laws of physics. Inertia. Where did the matter come from? Where did the inertia come? Where did the law of inertia come from? That's why I keep trying to point out, you guys just refuse. Either you can't see it, or you won't see it, or you won't admit it. There's not science to say all the matter in the universe came from a dot that's rapidly expanding. That's a fairy tale for grown-ups, is all it is. And
it's a simple extrapolation of taking the expansion of the universe as we see it and winding it back mathematically. In the same way that any mathematical equation, an equation in mathematics has to work both ways in order for that equation to be facilitated. You know, when you multiply something in an equation, you can substitute which way you put those numbers on either end of a multiplication table for the sake of an equation. Right. The same thing is true when we're talking about the Friedmann equation and running it forward to predict future events in terms of the expansion of the universe versus running it backward to predict past events within the universe. And what we see when we look at the Friedmann equation as it correlates to things like the cosmic microwave background is that predictions laid out for it, such as the fact that we would not see light propagating within the universe until some 250 to 300,000 years after the Big Bang, due to the fact that these particles, as you try to claim, it seems in your worldview, gold and silver and iron and all of these fully formed particles are just rushing out of this dot. That was simply not what the Big Bang theory postulates. It postulates that for 200 to 300,000 years, things were so dense due to the scale of the universe being much smaller at that point and things being much more dense and hot. That would therefore facilitate in an environment where you would not be able to see light. It would not be able to propagate because there's so many free electrons that it'd just be scattered all over the place. Light would not be able to propagate until about 300,000 years after the Big Bang. And surely enough, when we look at the cosmic microwave background, it correlates to microwaves, the longest wavelength that we have that's been red shifted as far as we can possibly see, to that time span when we run back this equation. So it has predictive powers, which is one of the many things in science that you conveniently missed out. You said experimentation and observation were critical parts of science, but prediction is another critical part of science. And cosmology has made many a prediction as far as what our universe is and what it entails and the properties of it. And this is a perfect example of that exact thing.
Okay, the science, what we observe is when we look at stars through a spectroscope, we see the colors like we see with through most things with a prism: red, orange, yellow, green, blue, indigo, violet. We see dark spectrum lines that are shifted toward the red, called the red shift. That's what we observe. Everything else you just said after that is interpretation of this data. The data is we see a red shift. The assumption is it's from the Doppler effect. I think that's probably a logical assumption, but maybe there's something else. Maybe something else may be causing it. We don't know. That they latched on that one right away. Wow, Doppler effect, the stars moving away. Bingo, all the stars move away. That proves Big Bang. We all started as a dot. Let's go home, boys and girls. No. There might be 40 more things come up in science that illustrate that explain the red shift. The fact is, we do see a red shift. That's the end of the facts. How you interpret that? You went off on a rabbit trail and chased him all over the woods about this. That doesn't prove the Big Bang. Doesn't prove all the universe was in a dot smaller than an atom. And so you said this dot was so dense and so hot. Where did the heat come from? You haven't even touched on where the energy came from. Where did time, space, matter come from? But that dot you have that you believe in, that dot had to contain all the heat of all the stars. All the stars in the universe had to have all that. I mean, all that dot had to have all the heat. That's a hot dot.
May I address that? Well, hold on, one topic at a time. Can I address that?
Where did the energy come from for that dot?
Okay, so the energy is a consequence first and foremost. Like you just tried to extrapolate. Well, heat and energy. I'm not even talking about heat. It's energy is another problem. Well, that heat is a consequence of that energy. And as I said at the very beginning, that energy and the amount of energy that was present and where that energy came from is not, once again, something that the Big Bang attempts to explain insofar as where it got there. But you just made a critical mistake. You said the energy in all of those stars was already there. No, it wasn't, Kent. The potential for all of those energy, for the energy of all of those stars was there. That's what was present, was the potential for that energy to become all of the stars that we see in our observable universe today. We didn't see a bunch of stars and a bunch of planets and a bunch of, all these different well-formed objects just pouring out of an explosion. That's not what the Big Bang has ever postulated as far as a theory is concerned. What we do say is that the energy would eventually become stars and planets, and we can observe through experimentation that yes, pure energy can actually become particulate matter. It can become matter, and I could give you an example of that if you would like.
Well, no, you're off track already. Einstein's equation, E equals mc squared. Energy equals the mass times the speed of light squared. It's an algebraic equation. You can do it either way. So you're going to have either matter or energy. Einstein may have been right that the matter times the speed of light squared is the energy. Either way, you don't have an explanation. And you've said several times, it's not part of the Big Bang. It's not part of the Big Bang. That's my point. You don't have a starting point. You don't have a logical starting point.
Only religion requires a starting point, Ken. That's the only institution that requires a starting point. You insist that it requires a starting point because you think that it needs to be a religion when it's not. The only people that would ever insist that something need a starting point in order to be valid is somebody that has a religious perspective, because it is only the job of religion to try and explain everything and anything about the world in which we live within. That's not the purview of science. So stop trying to place it upon it.
Aiden, you are trying to explain everything. You have a religion. You just said that's what a religion does. You demonstrated you have a religious belief in the Big Bang. You don't know where time came from, energy, space, matter. You just say that's not part of the theory. Well, if I said, well, let's start with the assumption elephants can fly, and I go on and build a whole story about elephants flying. Stop. Elephants can't fly. My whole theory is gone after that. Your whole theory is dumb after you can't explain where time, space, matter, energy came from. Your whole theory is a religious belief based on something you don't know. You say, well, it's outside my theory. Well, how elephants learn to fly, that's outside my theory. But we know elephants can fly. Therefore, don't you see what you're doing?
Are you saying it's physically impossible that an elephant could ever fly?
with his own wings, I think that's physically impossible. But put dynamite.
Sure,
behind it.
given those very specific parameters, sure, but that we're not talking about that for the sake of this argument. You're kind of shifting the theoretical goalposts as far. Sorry.
All
somebody
right,
had-
gentlemen, if I may, the 10-minute segment for questions back and forth is come to a wrap. So if you guys would like, we can begin our 5-minute closing statements, and then we have about 7 questions marked that you guys can each answer after your closing statements, if that works for both of you.
Go for it. Go ahead, Aiden.
All right, Aiden, we will let you close out first.
Sure. Okay. So as far as cosmology is concerned and describing the history of our universe as we understand it, I was not able to get into the entirety of the body of evidence concerning cosmology related to the Big Bang. But suffice it to say that anybody out there in our current information age can readily go and look up things such as the Friedmann equation. They can go and look up things such as Hubble's law, and they can look up things such as the redshift. And they can determine that in spite what Kent says in relation to the redshift, that it is not, in fact, this caused by the Doppler effect. I was only saying that it was related to the Doppler effect as in terms of an analogy, because yes, indeed, in the Doppler effect as an example, those waves will propagate in a certain way whence it is in relation to sound, but that doesn't mean that the red shift is caused by the Doppler effect. That's just simply not true. They're just analogous to one another for the sake of the argument. No, redshift is something that we see as well as blue shift in our universe. It's not necessarily a uniform thing. And the reason why we see blue shift as well as red shift is because sometimes gravity, when things are localized enough with one another, the Andromeda Galaxy and the Milky Way Galaxy are a great example of this, that gravity will overcome the expansion of space at sufficiently small distances. Because one of the properties of Hubble's law is that in taking the example of the balloon that I provided earlier, when it is inflated, say, once again, we extrapolate that example further to a point of 9 dots on that grid. You expand that balloon, you blow it up, and you look at all 9 of those dots on that balloon, and you see that the amount of space is actually increasing. The amount of expansion is increasing from one side of that 9-pointed grid to the other, because now you don't just have to take the distance between 2 points on that grid into account. You have to take the distance between both sides of the center into account and add both of those together to determine the total amount of expansion between those on the grid. That's an example of Hubble's law. All right, those are things that we observe. We see that the universe is expanding, and most importantly of all, the expansion that we see at the rate that we see correlated to the redshift would not be possible if the universe was 6,000 years old, because if it was stretched out as rapidly as Kent is claiming, where suddenly 6,000 years becomes 13.8 billion, then it would be redshifted so far to the point where we would only be able to see the universe 6,000 light years around us. This and many other examples are reasons why cosmology differs from Kent's cosmic evolution. Kent tried to say that he likes cosmology, that he's in favor of cosmology. He loves it, as a matter of fact. And if only people like me had learned the truth of it, then maybe, just maybe, we might be able to have a decent debate. See, he got the thumbs up. But my contention is that the reason why Kent uses the term cosmic evolution in place of cosmology is because cosmic evolution, so-called in his worldview, is one of the many steps in which he tries to say that evolution needs to fulfill the same categories of his religion. Somehow, the theory of evolution, in spite of it just being something that relates to the biological evolution of life, somehow it needs to be able to explain and encompass everything about the reality in which we live within. And that alone shows that Kent is not interested in the specific academic disciplines of these things. He is trying to make evolution into a religion, and he is failing at doing so. He wants it to be able to express all of the same dogmas and all of the same aspects of his religion, as far as its ability not to change, and as far as having to explain literally everything about everything. But it just simply doesn't. So, in conclusion, I would say that the evidence available for everyone in the audience, as far as which outlook of the universe is true, is available readily for everyone to look at through all matters of sources, whether it be secular or religious. Kent, please go ahead with your conclusion.
Thank you. Well, the people who are involved in this study call it cosmic evolution. Okay, you want to call it cosmology? It's included. Okay, so the study of cosmos is wonderful. The cosmos is everything, all the stars, the whole universe. That's the cosmos, and the study of it's wonderful. So they do talk about cosmic evolution from Big Bang to humankind. Whoa. Okay, right center for science education. Here we go. Why cosmic evolution matters. A crash course in big history. Okay, let's see. Cosmic evolution definition and meaning. Collins Dictionary. Religious humanists regard the universe as self-existing and not created. At least they admit they're religious. This Big Bang theory is part of a religion. You don't know where the energy came from. You don't know how all the matter got created or where it came from or where it existed 10 seconds before the Big Bang or 2,000 years before the Big Bang. Is time eternal? If you can go forward and backward in time for eternity, well then how are you going to get from the beginning to 13.7 billion years ago? Because time's eternal. It goes backwards and forward. So did time have a beginning? And I say yes. In the beginning, there's time. God created the heaven, there's space, and the earth, matter. God made time, space, matter. He's not stuck in any of those. I'm stuck in time, space, matter. So are you. God's not. So they do teach the Big Bang. Matter and energy cannot be created or destroyed. It can't be. So where'd it come from? You got to have a starting point, and you skip right over this and say that's not part of the theory. That's like me starting. Suppose I had a herd of elephants that could fly. Where's my starting point? How did we get the elephants? How did they learn to fly? You're skipping over the important part of all this. First law of thermodynamics: that heat, energy, and thermodynamic process are therefore subject to the principles of conservation of energy. This means heat and energy cannot be created or destroyed. So where did all the heat for these stars come from? If it can't be created or destroyed, where did the energy come from? You skipped it, Aiden. I'm sorry, you don't have an answer. Einstein's theory, E equals mc squared. The energy and the mass are related to each other. And you're saying that the Big Bang rapidly expanded. Let me explain it one more time. I think nearly all the audience sees this, okay? If there are two dots an inch apart on my balloon, and I blow up the balloon to twice the size, and the dots are now, they would not be, pick a number, say they're 3 inches apart. I can calculate if you like. They're certainly farther from the center, and they're farther from each other, but I'm definitely going to use that one when I get stopped for speeding. Officer, I was not even moving. The space between me and that other car was rapidly expanding. I didn't move at all, officer. Give him a ticket. I'm going to use that one. Okay, I think I win the debate. There's no evidence whatsoever for this cosmic evolution theory. There's no evidence for it. You don't have an answer. Where did time, space, matter, energy come from? You certainly don't have an answer for the organization of matter. That's another major problem in the evolution theory. I just simply point out, you guys believe that this happened. Great. You can believe all you want, but it's not science. You're polluting science. Science is where we can observe, study, test, and demonstrate. You cannot observe the Big Bang. You cannot observe matter expanding and gaining energy. If the stars are accelerating, where's the gas pedal? If space is stretching, where's this energy come from to stretch the space? Stars are pretty heavy. You want to move them and accelerate their movement? It's a real dumb theory in my humble, totally unbiased opinion. And my book on the world's 3 most humble people and how I trained the other 2 will be out soon. Okay, thank you.
All right. Well, thank you guys for that. And I thought it was a very interesting debate. We have 8 questions lined up. So if you gentlemen want to jump into the question portion, we'll try to make that go quickly and free you up, Dr. Hoven. All right. So our first question is for Proverbs Guys Ministries, but either of you can answer this. It's, can you list the features in our solar system that formed as a result of the fountains of the deep? And Dr. Hoven, I'm going to guess that's directed to you.
Yeah, he said that on the next comment, but yes.
Okay, the Bible says the fountains of the deep broke open. I believe the earth was created with a layer of water under the crust of the earth. Scientists are now admitting there's probably 10 oceans worth of water in the crust of the earth still to this day. We know that there are hot thermal vents in the bottom of the ocean, like 10 million of them is the estimate. They go down in the submarines and they see hot water squirting up into the bottom of the ocean. Well, then where's it coming from? Lower than that. I think the crust of the earth used to have water under the crust. that split, the crust split, and the fountains of the deep broke open, and that's where most of the flood water came from for Noah's flood. So how does that? I don't think it affected the solar system much, unless the fountains of the deep were under such pressure from 10 miles of rock on top that it launched some of the rocks on the edge up into space, and they might have formed the craters on the moon. Moon got hit like a shotgun. That's just a theory. I wouldn't claim that I could prove that. But it's interesting, the craters on the near side of the moon are much bigger than the craters on the far side, indicating some of the stuff must have shot past and got pulled back in by moon's gravity, which is a lot weaker than ours, and made littler craters. So I believe it's a reasonable explanation that Noah's flood might have shot stuff up into space and caused some of the debris still floating around. And as we travel around the sun at 66,000 miles an hour, we smack into it like bugs on a windshield, and we're still getting hit all the time. Probably from stuff that launched off the Earth. Just a wild theory. Go ahead.
Allow me to interrupt, Brother Stephen, for some context. First off, Dr. Hovin answered two questions. The other one was the fake profile of Claude, who was asking about the moon. And he was trying to say that it's a bad religion that Ken Hovin has because of this theory of the moon, and Ken Hovin just answered it, and he said, "That's just a theory. I don't have proof for it, but I'm just saying." So I think he got that answered also nailed. And just to point out to Ken Hovin that this Ajax person that asked that question that you just answered was your favorite creationist crybaby. And he's hiding it behind another profile, but creationist crybaby is our favorite one.
I mean, he's not hiding though, but he gets banned. Is he?
Achilles was absolutely right on that. Hovin explained that's just
gentlemen,
part of his.
We're going to move on to the
theory
next
and not
question.
actually part of
And
cosmology.
I believe this is also for Dr. Hovin, but Aiden, you can answer afterwards also if you'd like. And it's, can the Big Bang be how God created the universe? Dr. Hovin.
Well, there's no evidence for the Big Bang. Why would I accuse God of doing something dumb like that? I think the God that I would worship would be a God who makes everything perfect first time. It was perfect. At the end of 6 days, God looked at everything, said it was very good. Then man messed it up. So I think no, I would not. It's certainly not the Bible teaching. Okay, and I don't think there's any evidence for the Big Bang. Why should I try to compromise a perfectly good book which has never been proven wrong with a dumb theory that's never been proven right? So no, I wouldn't accuse God of that. That would not be a God that I would want to worship. How's that?
Fair enough. Aiden, would you like to also address that question or pass?
Sure. I mean, the notion of the God of the Bible not fitting within Kent Hovin's purview, if that were to be the case, that he would not want to worship him, being a little silly aside, I think the notion that God created the universe through the Big Bang is just as good of a notion as the idea of what's postulated in Genesis, simply because the fact is that we don't know what happened directly before the Big Bang. We don't know whether it was a naturalistic cause or not. We don't know because it's not what the theory describes. And Kent's big contention is that, well, you need to be able to have something before that in order for it to be a good theory. That's great that it doesn't meet his personal definition of what a theory should be, but that doesn't necessarily mean that it isn't a perfectly good encompassing theory at what it is actually theorizing and what it is there to do, which is to describe the rapid expansion of the universe directly after t equals 0, not explaining anything before t equals 0. So his contention was okay. No, go ahead, Stephen.
No, and this next question is for you, Aiden, so I'll let you answer first, and then Dr. Hovin can comment if you would like. The sun is billions of degrees in temperature and 1 million miles away, yet perfect to ripe the tomatoes in your greenhouse. How is this possible by no guiding hand for Aiden?
Sure. Well, as far as the distance of our sun correlated to where we are on our planet, you're referring to what's known as the Goldilocks zone. And the Goldilocks zone is a concept within cosmology stating that a object like a planet has to be a certain distance away from its home star in order to facilitate temperatures necessary for life. And this is true. As a matter of fact, there's actually 3 planets within our solar system that fall within this habitable zone. Now, 2 of those planets fall within the extreme ends of that habitable zone. Venus falls within the extreme end in terms of heat, and Mars falls within the extreme end in terms of coolness. But they are indeed both still within the habitable zone of our solar system as well as the Earth. Now, they both lost the things required for them to be able to facilitate life through different means, but that's a different story. My direct refutation to that would be that it's not necessarily a special thing. We can observe through through the barycenter of very different distant stars, wobbling around. We can see through the wobbling of these stars around their respective gravitational barycenters that they do indeed have planets orbiting them. And based on how much they are wobbling, we can determine not just the mass of those planets, but we can determine how far away they are. And we have determined that planets as close as Proxima b, which is orbiting Proxima Centauri, very close to us, falls within its habitable zone. So just being close enough to a star to be able to facilitate temperatures for life is not necessarily in of itself a unique thing. I'm sure Kent would express, maybe I'm wrong, tell me if I am, Kent, but I'm sure that you would express that, well, it's not just the Goldilocks zone that makes the planet habitable. It's all kinds of different factors on the planet that allow the planet to be habitable. And I would readily agree, but I could show you examples of different combinations of those factors all over the place in our universe. So yeah, that's my answer.
All right, Dr. Hoven, if you'd like to take a whack at that question, you're also welcome to. Goldilocks zone, how could that happen without a guiding hand?
Well, I think it was a guiding hand. I think he made it perfect. And we're looking at the wobble of a star, but long ways away, and determining the size of the planet orbiting it. Most of the stars are bigger than our sun. Have they determined if that planet would have the right gravity, not just the distance from the star? That you're saying you can determine the distance of a planet from the star by the wobble. I find that hard to believe, but I'll give you that, okay? That still would be just one of thousands of factors. Besides, that's only the temperature, okay? If a planet's too big, there's too much gravity. Earth has just the right gravity, has just the right atmosphere to stop some of the UV light. Otherwise, it would burn everything on there, destroy everything. So to ripen the tomatoes in your greenhouse, I think God is really smart. He made it all just right. We got to have liquid water. Where'd that come from? You got to have, lots of the Earth is not habitable. The Earth is in a habitable zone, but you can't live. A lot of places on the Earth. Drill down 30 miles and see if anything can live there. Not a bacteria. Nothing can go just 30 miles below the surface. And it's 8,000 miles in diameter. A lot of the Earth is not habitable. So I think it's silly to believe that there's other stars that may have life on there because we see a wobble in the star. Maybe the telescope base is loose.
Well,
maybe
hold on.
Maybe the astronomers
Hold on. I would like to just say something. The idea that what I was saying was that there was life on other planets based on the fact that other planets fall within their habitable zones is a bit unfair, Kent. That's not what I was saying. I was simply saying that the conditions outlined by that person, those conditions being a sufficient distance away of a planetary object from its home star, are indeed things that we observe in other portions of our universe. So I think it's unfair to say that that's me saying, oh, well, that just must mean that there's life other places. I do think that, but I think that that's due to a myriad of other factors that are totally unrelated to the question.
All right, let's jump into the next question. This one is actually for both of you. How is it possible that we can see objects that should disappear behind the Earth's curvature on a globe Earth? So they slipped this one in on us, but Doc, I'll let you answer it first.
The Earth is round. It's about 8,000 miles in diameter. It's spinning toward the east. It's going about 1,036 miles per hour at the equator. And I cannot get on a tall building and see Tokyo. I cannot get on a tall building and see Chicago. I can see things, depending on how tall my building is, I can see out to the horizon. But if the Earth is indeed flat, this is one of them dumb flat Earth questions, how do we ever get darkness? How does it ever get dark? Why do we have time zones? Why can I call somebody in England right now and they'll tell me, wow, it's 10 o'clock at night over here? Why? How do we get time zones? There's just, I was so tempted, Stephen, to get into this flat Earth debate and just really get all the reasons why it's dumb. So you can believe whatever you want, and you will, okay? But it's not, only Kansas is flat. The rest of it's round, okay?
All right, Aiden,
There
you
you
can
go.
now answer this question, and I have a funny feeling this will be the one question of the night you gentlemen agree on. So,
Hey, you're really gonna take the thunder out of my comment like that. I was just about to say, finally, here's something that me and Kent can agree on. The idea of a flat earth, stupid, outdated idea, needs to be discarded to the dustbin of history. There's one thing that we can at least agree on. It's like the one question in every presidential debate that's like, can you guys say one good thing about each other, please? That's the equivalent. Anyways, I think that it's dumb because of something known as atmospheric lensing. It's the reason why we can look at the masts of ships, even though they go over the horizon of the curvature of the Earth, so to speak. It's because our atmosphere is also curved in the same way that a curved lens will refract light differently than a straight lens will refract it. The same is true for our atmosphere. You'll be able to see light, you'll be able to see objects as a result of that atmospheric refraction further away than you actually would be able to see them on a flat Earth. So when they ask this question, they don't realize that they're actually inadvertently arguing for a round Earth, because if it was a flat atmosphere, there would be no lensing.
All right. So thank you for that, gentlemen. We have two more questions. And then Dr. Hoven, will thank you for your time. I know you're busy and you have to prepare for your next debate with Standing for Truth here very shortly. So the question for Aiden is, how do you explain the position of non-locality in quantum physics with evolution?
So the position of non-locality in quantum physics. So are they
I have no
talking
idea what
about
that
like
means.
quantum superposition in regards to non-locality? Because if they're
The
talking
question was a little vague. I read it word for word and it is on the screen, but as far as digging in deeper to what he meant, I can't
So
help you there.
subatomic,
Yeah, no, I think you
subatomic
might be
particle
talking about
physics,
quantum superpositioning.
evolution.
I think. I'm not going to pretend like I'm a quantum physicist by any means. That is certainly not
Locality.
my department of expertise.
Yeah.
But what I would say in terms of quantum mechanics, and one of
Maybe
the things that
Shofar was
wasn't
screwing with
brought
him.
up is I'm
I
not
don't
going to
know.
pretend like I have an answer to that because I'm not quite sure what you're talking about, Shofar. So I guess that's my initial answer. But I think to kind of pivot it into something that I do find interesting. One of the things that wasn't brought up that I thought would have been interesting is the speed of light, in terms of the fact that the speed of light has been slowed down in laboratory settings. And, oh, well, look at us. We've slowed down light in the laboratory settings. So that means that the speed of light that we observe see, it can't be a constant, because look at these examples where we've slowed it down. Well, in quantum physics, we have an example of, well, first and foremost, we have to establish the fact that we only determine distance based on the distance light travels in I think it's 1/299 millionth something of a second. That's how we determine distance. But when it comes to light, when it interacts with something solid like water or steel or something like that, and when it passes through a medium, it is indeed slowed, but it's not slowed in the way that we think of, at least in terms of what we understand in quantum physics, because we must remember that light as a property of our universe is more than simply charged particles or waves that do whatever we are that they are electromagnetically ordered to do. In the world of quantum mechanics, an entity similar to the proton, the phonon, is created when the proton interacts with the vibrations associated with any solid object when it's interacted with, because after all material is constantly in motion via these vibrations. So when we're looking at light as it passes through these mediums of materials, we're not looking at light as a photon and a magnetic wave. We're looking at it, or an electromagnetic wave. We're actually looking at what's known as a phonon. And that may sound silly as far as an explanation is concerned, but that would have to be true in order for quantum mechanics and quantum computers, specifically as we know them, to work. So maybe I wasn't able to answer your direct question, but I hope I gave you an interesting answer that was related to quantum mechanics, at least.
All right. Well, the last question of the night, I believe it's for both of you.
I want to talk
why
about
has
that quantum mechanic answer that he just gave too
created more
eventually.
controversy about the age of our universe and its origins? Also, the supposed redshift could create what we see if God stretched out the heavens, if you just understood. So, Dr. Hogan, we'll let you answer that one first.
Well, who is JWST? What is that?
That's the James Webb Space Telescope is what they're referring to.
Okay. Why has it created more controversy about the age of our universe and its origins? I think before they even put the thing up, somebody said, what do you think they're going to see with the telescope? I said, they're going to see more stars. And they did, lots more stars. And now they've had to double the age of the Earth from 13.7 to 26 billion years old. just like that. They can change it whenever. And of course, they're never going to bring it down to 6,000, but they keep adding more time because time is the pacifier that keeps them happy. You got to have lots of time to turn your frog to a prince, and to create your frog out of chemicals. So, I think why has it created more controversy? I think that proving the age of the Earth is a difficult thing scientifically. There are some limiting factors, like the fact that it spins but it slows down, the fact that the oceans are getting saltier. I've been covering a lot of those on Genesis Baptist Church channel on YouTube. You can go to Genesis Baptist Church and watch every Friday night for quite a while. I've been covering different scientific ways to show it just simply can't be billions of years old. Like if I told you this ink pen was 5,000 years old, I could easily prove that wrong. Ballpoints weren't even invented until 1988. Well, that one fact proves it wrong. It's not 5,000. I think there's lots of scientific indicators that say this Earth simply can't be billions of years. Now, Aidan and others like him need billions of years for their religion to sound true, but it's nothing but a religion, and it's not science. And you don't have billions of years. So I don't know what the telescope proved. Go ahead.
Okay, so just really quick to your claim before I get into the question. It's actually not true. We don't need billions of years in order for our scientific theories to make sense. If the scientific evidence that we have, right, like if we looked out at our universe and the shell of stars that we could see around us only extended to 6,000 light years away, then I would be the first one, Kent, to line up right behind you and say that the evidence for the universe in terms of C, in terms of the speed of light in a vacuum correlated towards redshift and the expansion of the universe would point towards a universe that is 6,000 years old. I would have to agree with you because that's what the evidence would indicate. However, that's not what the evidence seems to indicate. The evidence indicates that not only is the light that we can see stretching much, 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 much further than 6,000 years, but we can show that if you do accelerate space through the expansion of that space fast enough at a sufficient distance through Hubble's law, as I described earlier, you will see that objects further away from us will recede faster and faster away from us the further away from us they are. This is what creates the hard light barrier that we observe of our observable universe. That is not found 6,000 light years away. Now, why has James Webb Space Telescope created more controversy about the age of our universe and its origins? Well, the reason why that's the case is the same reason why the Hubble Space Telescope did the exact same thing. It's the reason why the International Space Station did the exact same thing. It's because, as I said at the beginning, science is simply an endeavor of trying to understand specific parts about the world and how it works, using experimentation, using repeatability, and observation, not just direct observation, but observation through all manner of different means, such that it is consistent beyond reasonable doubt. And the thing that operates that, the engine that makes that work, is information, is data specifically. And the James Webb Space Telescope, just like the Hubble and all of them before it, are there to gather more data. They're there to gather more information. So I'm not surprised that it has shed new information and it's changed and altered our understanding of the universe. That's only to be expected from a scientific perspective. Now, the supposed redshift could create what we see if God stretched out the heavens if you just understood. If you could demonstrate to me how you could redshift light billions and billions and billions of years outside of what it would have been at an instant before, where it's stretched the way that Kent talks about, if you were able to demonstrate a way for that to happen without it becoming redshifted, then once again, just like I said at the very beginning, I would only have to stand behind Kent and agree with him because that's what the evidence would indicate.
All right. Well, gentlemen, that was a great back and forth, and thank you both for keeping the debate civil. It was very productive. Thank you both for your time today. Dr.
You know,
Hoban,
that
thank
was
you.
a good debate. What did you guys think?
I'm out of your busy day because I
I thought that was excellent. I would love to see another debate just like this debate.
Showing up and keeping
I think this debate was a fine debate, and Stephen thinks it's a fine debate. Achilles made a good point. You know, Achilles made a good point there. I heard about science and theory, and
never ended up having to resort to calling your ideas stupid over the entire course of the debate. So there is that. You have a good
well,
one.
That's true. You guys did not call each other.
I think there's one more thing we can agree on.
That's
you're going to die one day.
Thing you can.
So am I.
Oh.
Then what?
Oh,
Ready
he's
for that.
got me.
All right. See you later. Bye.
I believe.
All
Just kidding,
right.
goodbye.
Yo, go video with that. It's so funny. Anyway. Man, that is a funny way to end a debate, though. That question, the gotcha question was oh, those death questions. What a mind something. Anyway. So yeah, I hope you guys enjoyed that. We watched through that. I do have another video to watch. I don't know if Jason's around or not. If he's not, this will be all, folks. So, booty me down. I guess I'm gonna close it down, guys. You all have a great night. Hardy har. Robin, thanks for sticking out to the end. If you're traveling, God bless, and stay strong. And don't worry about the eclipse too much. It's just a rock moving in front of a light source. Don't worry about it. Take care.